For a long time, many people have believed that humans are the first and only intelligent beings to live on Earth, creating cities, developing technology, and sending machines beyond the planet. However, this idea may not include every possibility. There is a question about whether another advanced civilization could have existed on this planet long before humans, one that was intelligent, highly developed, and now no longer present. Could something more advanced exist millions of years ago and then disappear, possibly leaving behind unusual objects such as tools, carvings, or structures that we cannot yet explain? Or could the Earth have preserved the remains or traces of such a civilization beneath layers of soil and rock over long periods? Before we start this journey, let us know where in the world you're watching from and what the time is for you now. Drop it in the comments below and settle in for a fascinating journey. The Silurian hypothesis is a bold and very interesting idea that challenges everything we think we know about human history. It asks a deep and surprising question. What if human beings are not the first intelligent civilization to rise on Earth? What if, millions of years before us, there was another advanced society, one that built technology, explored science, and maybe even reached for the stars, only to disappear completely, leaving behind little or no trace? This idea was introduced by two scientists, space scientist Adam Frank and planet scientist Gavin Schmidt. They wondered whether Earth might have once been home to intelligent life forms long before humans ever appeared. If such a civilization existed, could all signs of their presence have been wiped away by nature itself, by volcanic eruptions, earthquakes, erosion, rising seas, or changes in climate over tens of millions of years? Unlike usual archaeology, which focuses on the rise of human civilizations over the past few thousand years, this idea stretches far beyond our known history. It dares us to think that civilization itself might not be unique to humanity. Perhaps it is something that has happened more than once during Earth's 4.5 billion year history. At the center of this idea is a simple but strong thought. Maybe humans are not the first, and maybe we are not the only intelligent life to walk this planet. If another civilization once existed millions of years ago, most of their buildings, cities, and machines would likely have broken apart. Natural processes, like moving tectonic plates, rising mountains, eroding coastlines, and even asteroid impacts, could have erased nearly all signs of them. That's why scientists looking into this possibility aren't just searching for statues or ruins. Instead, they're searching for more quiet, indirect clues. These might include unusual chemical marks buried in rocks, strange layers in ancient sediments, or odd patterns in the Earth's isotopes, tiny atomic fingerprints that might suggest past industrial activity. Finding such hints is difficult, but not impossible. The big problem is that Earth's geological record, the layers of rock and sediment that tell the story of our planet, is incomplete. Over millions of years, much of it gets crushed, melted, or recycled by nature. Normal archaeology depends on objects like tools, pottery, and bones, things that rarely survive beyond a few 100,000 years. So if a civilization lived on Earth, say, 50 million years ago, almost everything they built would be gone. That's why the Silurian hypothesis calls for a different approach, one that brings together many parts of science. It's not just about digging up old objects, it's about combining geology, chemistry, climate science, and even computer models to look for deeper clues buried in Earth's history. This idea doesn't just challenge how we search for the past, it also asks us to rethink what we mean by civilization. It opens up big questions. How long can a technological society last? Do civilizations rise and fall like waves over time? Could our own be one in a long line of many? And what happens when a civilization collapses? Does it leave any mark that survives? Exploring these questions forces us to rethink not just the past but also the future. If other intelligent species once lived on Earth, and if they disappeared without a trace, what might that say about us? Thinking about civilizations that might have existed before humans isn't just science fiction. It has real value for scientists and archaeologists. It helps us question long-held beliefs and expand our understanding of how life and intelligence grow over time. For a long time, historians and scientists believed that civilization followed a straight path. Early humans formed tribes, then cities, then built machines, and finally reached the modern world. This story made it seem like humans were the only ones ever able to create complex societies and advanced technology. But the Silurian hypothesis turns that idea upside down. If a civilization rose and fell millions of years ago, we might not find stone buildings or metal tools. Instead, we would need to look for quiet signs, like strange chemical leftovers, odd rock patterns, or even unexpected minerals that might suggest industrial processes. These marks might be buried deep underground or hidden in the ocean floor. Finding such signs would be one of the biggest discoveries in human history. It would force us to rewrite everything we know about life on Earth. It would also raise new questions. How long did that civilization last? What caused it to collapse? Could the same thing happen to us? And there's another layer to this story, one that goes beyond science. The idea that humans might not be the only intelligent beings ever to live on Earth shakes up our sense of importance. For centuries, people have believed that we are the center of everything. From ancient religious teachings to Enlightenment science, humanity has often been seen as unique, special, even meant to rule the world. This belief was strengthened by the complexity of human language, culture, and technology. It made it seem unlikely that any other species, on Earth or elsewhere, could match our intelligence. And because we've never found strong evidence of alien civilizations or prehuman ones, many assumed they didn't exist. But as our tools grow more advanced, and as we learn more about the history of our planet, that confidence is starting to weaken. New discoveries in fields like astrobiology, planetary science, and deep-time geology suggest that we may have been too quick to dismiss other possibilities. The Silurian hypothesis encourages us to be open-minded. It reminds us that intelligence might not look like we expect. It could appear in forms and places we've never thought about. And if civilizations can rise and fall, here on Earth or out in the stars, it's worth asking, what will future beings think of us? Will we leave behind anything they can find? The belief that humans are special has been with us for a very long time. During the Renaissance and the Enlightenment, roughly between the 15th and 18th centuries, science began to grow. People started using careful observation and logical thinking to understand the world. But even as knowledge grew, many still saw humans as the center of everything. Back then, people believed Earth was the center of the universe, a view known as the geocentric model. Even when that idea was proven wrong, another belief took its place, that humans were the most intelligent and important species in the universe. Our ability to build cities, speak languages, and develop advanced technologies seemed to prove it. Some of these beliefs also came from religious or philosophical ideas. Many thought humans were specially created, set apart from all other creatures. Others believed that if intelligent life existed elsewhere, it would either be very different or far less advanced than us. Another reason people believed in human uniqueness was the lack of evidence for anything else. We hadn't found any signs of alien civilizations, nor had we found clear proof of intelligent life on Earth before us. From a scientific point of view, this possibility pushes researchers to look more carefully at the clues left behind in rocks, fossils, and ancient layers of the Earth. Our current tools, like radiometric dating and stratigraphy, which studies the layers of the Earth, are designed to detect natural changes over time. But what if there were signs of advanced technology buried deep underground? Signals so faint or so unusual that we simply overlooked them or mistook them for something natural. Scientists may need to go back and study the fossil record, layers of sediment and chemical compositions in a new way, looking for things that might have been built or shaped by intelligent hands. These signs could be tiny, hidden, or damaged by time. Over millions of years, metal might rust away, buildings might be crushed or buried, and only strange patterns or chemical leftovers would remain. The big question is, could the remains of a long-lost civilization be buried so deeply or broken down so much that we can no longer recognize them? From a philosophical point of view, the idea is just as powerful. If intelligent life once rose and fell on Earth before us, it would mean we're not necessarily the first or the only beings to reach a high level of knowledge and technology. That thought humbles us. It suggests that perhaps the rise of intelligence is not a rare miracle, but something that could happen again and again when the right conditions come together. It also makes us think more deeply about the nature of progress. Are civilizations like ours a natural outcome of evolution on Earth-like planets? Or are they rare and fragile, doomed to collapse after reaching a certain point? Could it be that other civilizations once existed here, achieved great things and then disappeared, leaving behind only hints that we're just now starting to think about. This idea also raises important questions about how long technology can last. Would the machines, tools, or buildings of an ancient civilization survive for tens of millions of years? Or would nature destroy them so completely that we would never even know they were there? If an ancient civilization changed the Earth's climate or left behind chemicals in the soil, could we detect those changes today? All of this ties into bigger ongoing conversations about life beyond Earth. The Silurian hypothesis, a name given to this idea by scientists Adam Frank and Gavin Schmidt, connects the possibility of ancient Earth civilizations with the search for intelligent life elsewhere in the universe. It opens up exciting questions. If ancient intelligent life once existed on our planet, could other planets also have gone through similar cycles? Could life appear, rise to greatness, and disappear again and again throughout the galaxy? The idea makes us look differently at both archaeological mysteries and stories from ancient cultures. For example, what if the sudden jumps in ancient technology, or the sudden appearance of complex knowledge in early societies, were echoes of something older? Could myths of lost worlds like Atlantis or Lemuria be distant memories of real places that once existed? Civilizations so old that they were forgotten by history? The Silurian hypothesis also encourages scientists to study ancient ruins and puzzling artifacts more carefully. Are some of these things really just the work of early humans? Or could they be misunderstood remains of something much older, perhaps even non-human? This idea challenges the usual belief that all stories of gods, sky people, or vanished cities are just myths. What if some of them are based on real events from a time long before our own? Ancient cultures such as the Sumerians and Egyptians offer stories that hint at this possibility. The Sumerians, one of the oldest known groups, believed that their knowledge came from gods who came down from the sky. The Egyptians spoke of a time of disorder that was brought into order by holy beings, ideas that suggest something existed before humans, or at least before known history. On the other hand, many old stories describe history as starting with human beings and moving in a straight line of growth from simple to advanced. Religious texts often describe a moment of holy creation, after which human history begins, leaving no room for earlier intelligent life. These stories seem to reject the idea of societies before our own. Still, there are legends and strange archaeological finds that keep the debate alive. Plato's well-known story of Atlantis describes an advanced society that disappeared under the sea. While many scholars see it as symbolic, others wonder if it could be based on a real place lost in time. Huge structures like the Great Pyramids of Egypt or Stonehenge in England raise similar questions. Did ancient people really build them with the tools we think they had? Or did they get knowledge from a much older, forgotten source? Mainstream scientists are often careful and prefer to see these ancient stories as myths or figures of speech, not exact history. But the Silurian hypothesis asks us to stay open-minded. Instead of ignoring ancient tales or unexplained findings, maybe we should take another look, with better tools and new thinking. To carefully test the idea behind the Silurian hypothesis, the suggestion that an advanced group may have lived on Earth long before humans, scientists turn to three major fields: geology, paleontology, and archaeology. Each of these areas of study brings a different set of tools and knowledge to help us explore the very long and complex history of our planet. Geology is the first and most basic field. Geologists study the layers of rocks, the minerals they contain, and how these layers are arranged over time. This gives us a record of Earth's past that goes back for billions of years, far beyond anything written in human records. One of the most important tools geologists use is radiometric dating, which helps them figure out how old rocks are. For example, they can study volcanic ash trapped between rock layers and use isotopes, tiny forms of elements that change over time, to tell exactly when that ash fell. This lets scientists build a trustworthy record of Earth's events. Now, suppose they discover something strange buried deep in the Earth, unusual mineral layers, huge breaks in ancient rocks, or signs that something extremely hot once moved through. These odd things, if they don't match known natural processes, could be clues, hints that maybe, long ago, some intelligent beings might have done something on this planet that left a mark. Paleontology, the study of ancient life through fossils, adds another piece to the puzzle. Paleontologists usually look at how life has changed and grown by studying bones, shells, and marks left in stone. But they also watch for anything odd. like a sudden change in fossil types, or something buried in a sediment layer that doesn't seem to belong, such as tiny man-made looking objects or materials with strange shapes. If these are not natural, they could suggest that intelligent life may have existed long before us and left behind signs of their technology or impact. Archaeology, often thought of as the study of ancient human groups, can also look much deeper into the past when it studies very old, unexplained objects or materials. Modern tools like spectroscopy, electron microscopes and chemical tests help archaeologists find out if a material was made naturally or created by intelligent beings. If scientists ever discover strange metals, special mixes of metals or man-made compounds in ancient rocks, especially in layers dating back millions of years, it might suggest the work of a long-lost group. These three fields, geology, paleontology, and archaeology, come together to form a strong combined way of looking for signs of ancient civilizations. By bringing together rock timelines, fossil records, and possible objects, scientists look for patterns that don't make sense under current ideas. And because this method uses more than one type of evidence, it helps make sure that any claims of a past advanced group are supported by strong scientific proof, not just wild guesses. If such proof ever did appear, it would mean we'd have to seriously rethink everything we thought we knew about life on Earth. The scientific process is designed to be very careful and doubtful, making sure any unusual find is not just the result of natural processes, but if something truly surprising were found, something that points to a real, intelligent group from long before humans, it would be one of the most important discoveries in all of science. If the Silurian hypothesis turned out to be true, and we learned that a group as advanced as ours, or even more advanced, lived on Earth millions or even hundreds of millions of years ago, it would completely change how we see ourselves. Right now, most people believe that humans are the first and only species on Earth to build cities, create technology, and explore space. But if another intelligent species had already done something similar long ago, it would show that advanced life might not be as rare as we think. It could mean that the forces of evolution may have produced smart, tool-using beings more than once on this planet. This would also make us question just how steady and safe our planet really is. If an earlier group once lived and then disappeared, maybe because of war, climate change, or a natural disaster, what does that say about our future? Could the same thing happen to us? If they changed the planet's surface by mining, building huge structures, or causing environmental harm, and that harm can still be seen today, it would show that Earth holds on to what we do for a very long time. It would raise serious questions about how long groups like ours can last, and how carefully we need to treat the world we live in. Geology and related sciences like archaeology and chemistry can help us find possible proof. But instead of clear signs like ancient tools or monuments, we might only find strange patterns in the way soil and minerals were laid down. These patterns are small and slight, but they could tell us if something unusual once happened, something caused not by nature, but by smart beings. One of the biggest clues is found in dirt layers. Normally, over thousands or millions of years, dirt, sand, and other bits settle into layers. But sometimes these layers don't look normal. They're too thick, mixed up, or made of strange materials. That can be a sign of something unnatural. Maybe large machines moved the Earth, or a civilization dug up and changed the land. For example, if we find layers full of made materials like metal bits, building waste, or man-made substances that don't belong in nature, it could mean someone was once living and building there. These materials might include special metal mixes or waste from factories, things that nature doesn't make on its own. Another important clue comes from chemistry, especially when scientists look at isotopes. Isotopes are types of chemical elements with different weights, and they usually appear in natural amounts. But if these amounts are suddenly off, say there's too much of one kind of lead or copper, it might mean that something, or someone, was changing them. That someone could be a civilization using technology, like metalworking or chemical processing. These changes in isotope amounts act like chemical signs, showing that something unusual happened in that place. If found in the same place as strange dirt or odd minerals, they build a stronger case that something man-made might have happened long ago. Minerals can also carry important secrets. Natural processes usually create minerals in expected ways, but sometimes, scientists find minerals that look like they were made under extreme heat or pressure. not from volcanoes, but possibly from furnaces, ovens, or factories. Imagine finding early ceramics or melted rocks stuck inside ancient layers. Those could be leftovers from old technologies like pottery or smelting. Some minerals might even look like factory waste, such as slag or melted glass, which wouldn't naturally form in that place unless someone had created them. When we put all these clues together, strange dirt layers, unusual isotopes and odd mineral shapes, they begin to tell a story. It's like reading a hidden chapter of Earth's past, one that may point to a forgotten civilization. But this kind of research is hard. Earth has changed a lot over the last several billion years. Volcanoes have erupted, continents have moved, oceans have risen and fallen, and meteorites have smashed into the ground. All these events can bury or erase proof, or even make natural things look like they were created by smart life. One of the biggest problems is that nature can sometimes make things that look like human-made objects. For example, certain minerals might form patterns that look like tools or structures. Without context, it's easy to make a mistake and think something natural is man-made, or miss a real object because it's too broken or hidden. Real proof of ancient civilizations might be so worn down or buried so deep that it's hard to see. Some objects may have chemically changed over millions of years. That's why scientists have to be very careful. They use advanced tools like high-resolution imaging, chemical testing, and studying rock layers to figure out whether something is natural or man-made. This work often brings together many fields – geology, archaeology, chemistry, and even physics – to put together the puzzle. Earth has also gone through major disasters. Huge volcanic eruptions, asteroid impacts, and sudden climate changes can destroy entire areas. These events could have wiped out any early civilization and buried whatever proof they left under thick layers of ash or rock. Sometimes, these disasters even create confusing signs. For instance, a layer of volcanic ash might look like a man-made concrete floor, or melted rocks from an asteroid impact might look like factory waste. Scientists must sort out these clues to find out what really happened. Luckily, today's scientists have powerful tools to help them. They can use satellite images, 3D scans of rock layers, and isotope dating to look deep into Earth's past. Radiometric dating, for example, helps tell how old a layer of rock or dirt is, sometimes down to the exact year, even if it's hundreds of millions of years old. These tools help experts figure out if something unusual in the rock record is due to nature, or possibly the work of smart beings. One especially interesting place to search is in and around old impact holes. When a giant asteroid or comet hits the Earth, it makes a huge crater and sends bits flying everywhere. These craters can hold unusual materials, like melted rock, glassy minerals, or rare metals, for hundreds of millions of years. If a civilization had lived during the time of an impact, the bits from that civilization might be buried along with the asteroid fragments. For example, if scientists found made metals or man-made materials in the same layer as an ancient impact, it could hint that smart life was around when the event happened. Sometimes, nature itself can help keep the secrets of the past, especially when something dramatic happens to the planet. Huge volcanic eruptions or powerful earthquakes can completely change landscapes and bury everything in their path. These kinds of events don't just destroy, they also help save things. When a supervolcano explodes, for example, it can spread ash across whole continents. This thick layer of ash settles and becomes part of the rock layers deep underground. Scientists can trace these ash layers across different parts of the world, almost like reading pages in a huge book of Earth's past. Now, imagine if an ancient civilization had lived before or during one of these huge eruptions. Their tools, buildings, or even traces of their presence, like changes in soil or strange chemical patterns, might have been buried under all that ash. Over tens of thousands or even millions of years, those layers could harden and protect whatever is trapped beneath them, keeping proof of forgotten technologies safely hidden inside the Earth's crust. Planet-wide disasters like asteroid impacts or violent geological shifts can also change the climate. These changes might speed up the decay of certain materials, but they might also create perfect conditions for saving them. For example, the extreme heat and pressure caused by a giant impact could form very unusual minerals. If scientists ever find those minerals in strange places, especially alongside other odd finds, it might be a sign of something more than just natural activity. It might point to the presence of a civilization that came and went long before humans. As we look deeper into Earth's past, these natural disasters start to look like both destroyers and time boxes. They can wipe out civilizations, but also freeze pieces of their world in time. That's why many researchers are asking new questions. Could the dirt at the bottom of the oceans or the layers of ancient ice near the poles hold hidden clues? Could these natural records contain traces of a high-tech civilization that vanished long before recorded history began? Deep-sea dirt and thick ice cores are like Earth's memory banks. They hold information about our planet's environment going back hundreds of thousands to millions of years. These natural records give scientists a unique way to look far beyond the reach of archaeology or written history. If any advanced society once lived on Earth long before humans, these hidden records might be the best places to find proof. At the bottom of the oceans, dirt builds up slowly over time. These layers hold a mix of mineral dust, bits of dead organisms, and tiny fossils. Buried in this mix, researchers might find strange chemicals, rare minerals, or unexpected metals. For example, very high amounts of gold, platinum, or rare earth elements, much more than what would occur naturally, could suggest activities like mining or metalworking done by some long-lost civilization. In the same way, cores of ancient ice taken from Antarctica or Greenland are also extremely valuable. These ice cores trap layers of ash from old volcanoes, tiny particles from the air, and even pollution. Scientists can study these layers and look for man-made chemicals, like factory gases or synthetic pollutants. If any of these are found in ice layers that are far older than modern civilization, it could suggest that someone long ago had the technology to create such substances. To find such tiny clues, scientists use very precise tools. Methods like mass spectrometry, isotope testing, and strong beam radiation allow them to detect the smallest traces of unusual materials. These methods can even tell the difference between minerals that formed naturally and those that might have been shaped or changed by technology. For instance, strange isotopes found in an ice core or dirt layer might show that someone millions of years ago was building things or processing materials in a way that nature alone would not produce. Because of this, deep-sea dirt and polar ice cores are now seen as some of the most powerful tools for uncovering the mysteries of ancient technology. They help us build a detailed timeline and allow us to match strange findings with specific moments in Earth's past. When combined with modern scientific tools, these layers might reveal proof of civilizations that vanished long before humans ever lived on Earth. But to truly understand what we're seeing in these ancient records, we also need to know when things happened. That's where the science of geochronology, dating the age of rocks and minerals, becomes extremely important. Without accurate dating methods, strange discoveries could be misunderstood or wrongly placed in Earth's timeline. Geochronology is the science that helps us put dates on ancient rocks, ash layers, and mineral changes. One of the most trusted methods is radiometric dating, which looks at how radioactive elements inside rocks slowly break down over time. For example, uranium-lead dating is often used to find the age of zircon crystals in volcanic ash. These crystals can be over 1 billion years old. When scientists find unusual materials or patterns in the same layers as these crystals, dating can help figure out if those things might be signs of technology from an earlier time. Another method, called argon-argon dating, is especially useful for studying volcanic eruptions. It helps place an exact date on the ash layers that might hold buried tools or strange materials. Thermochronology, which measures how long it has been since a rock cooled, can show when rocks were lifted up or covered, events that might explain how ancient structures became hidden or destroyed. Newer methods like isotope geochemistry also let scientists study changes in the environment. By looking at changes in the amounts of certain isotopes, like carbon or oxygen, scientists can spot big changes in climate or air. If those changes seem to match patterns we see today from human industry, they might be a sign that something similar happened long ago. However, using these dating tools the right way needs great care. Not every strange pattern means a lost civilization existed. Nature can make odd things too. That's why scientists must always check the setting in which materials are found, what's around them, what layer they came from, and what other clues are nearby. Even though modern geology has greatly improved our understanding of Earth's very long and complicated history, it still has some big problems, especially when it comes to finding signs of civilizations that might have lived on Earth before humans. These problems mainly come from how slow and powerful Earth's natural processes are and how they constantly reshape the surface of our planet. Because of this, finding any traces of ancient non-human civilizations becomes a very hard task. One of the biggest problems is time itself. If such ancient civilizations did exist, they might have lived millions or even hundreds of millions of years ago. Over such huge amounts of time, many clues they may have left behind, like tools, buildings, or even changes in the environment, could have been erased, buried, or hidden by natural forces. The Earth is always changing because of erosion, moving tectonic plates, volcanic eruptions, and layers of sediment piling up. These strong forces can fully remove weak or short-lasting signs of ancient life. For example, if a civilization used mostly wood, plant fibers, or other materials that break down easily, it's unlikely that much would survive after so many millions of years. On top of that, the scientific tools we use to study Earth's past have limits. Methods like radiometric dating, isotope study, and studying rock layers, called stratigraphy, are very good at helping scientists figure out the age of fossils, rocks, and other materials, but only up to a certain point. These methods become less trustworthy the farther back in time we look, especially when we're talking about hundreds of thousands or millions of years. So if there was an early intelligent civilization during one of these far-off time periods, we might not be able to spot it clearly, if at all. Another problem is that not all evidence is clear. Sometimes clues from ancient civilizations could be indirect, like strange chemical patterns in minerals, odd types of sediment, or unusual mixes of isotopes. These might look like natural changes at first glance. It takes a well-trained and careful scientist to notice when something might actually be the result of intelligent activity. But often, these small clues are missed or ignored because they don't stand out enough. There is also something called preservation bias. This means that certain places on Earth are much better at keeping ancient things safe than others. Dry caves, deserts, and areas with very stable conditions are good at preserving evidence for a long time. But places with water, heavy rain, or lots of volcanic activity tend to destroy or wash away objects quickly. So if an ancient civilization lived in one of these harsh places, there's a good chance we'd never find their remains. Because of all these problems, even though our scientific tools are strong, they still give us only a partial view of Earth's deep past. This brings up an interesting idea. Could it be possible that signs of an ancient civilization were erased by nature or hidden below the surface of the Earth? Or even more dramatically, could the signs have been wiped out by huge space events? This is where things get even more interesting. Scientists and thinkers have long been interested in the idea that events from outer space, like huge asteroid strikes, exploding stars called supernovae, or strong bursts of radiation, might have changed life on Earth. These massive events have the power to destroy whole ecosystems, reshape the surface of the planet, and maybe even erase all signs of civilizations that once existed. One of the most well-known examples is the asteroid that hit Earth around 66 million years ago. This giant impact caused what scientists call the Cretaceous-Paleogene extinction event, which led to the end of the dinosaurs. But it didn't just affect animals. That impact changed Earth's environment, climate, and surface in huge ways. It left behind a special layer of material filled with the rare metal iridium, as well as shocked quartz and a giant crater. These are things scientists can still find in rocks today. But if an intelligent civilization had lived before that asteroid hit, the impact might have completely buried their cities and objects under thick layers of debris or turned them into different kinds of rock through heat and pressure, making them almost impossible to spot. Other strong space events could have had similar effects. For example, a nearby supernova or a gamma-ray burst, huge explosions of energy in the universe, could have hit Earth with radiation. That radiation might have destroyed the ozone layer, changed the climate for thousands of years, and made it much harder for life to survive. Any technology or structures from a civilization at the time might have been broken down by harsh weather, rising oceans, or fast erosion. And these space disasters don't just happen alone, they can cause other events too. An asteroid strike, for example, could trigger volcanic eruptions, massive earthquakes, or long-lasting climate changes. These follow-up effects could further destroy or bury signs of civilization. This makes things even harder for scientists and archaeologists who are trying to understand what Earth was like in its far past. All of this shows that space events could play a major role in hiding or erasing the evidence of ancient civilizations. But here's the twist. They also leave their own clues behind. So while these disasters might cover up ancient signs, They also leave marks in the rocks that scientists can study, like craters, special chemical layers, and changes in Earth's surface. By learning how to read these marks more closely, we might one day find signs of intelligent life that lived long before us. And this brings us to a new and even more interesting question. What do fossils tell us about the possible existence of ancient civilizations that were not human at all? Sometimes, archaeologists discover strange objects or structures that don't seem to fit with what we think we know about human history. These unusual findings, often called archaeological oddities, raise big questions. They challenge our usual understanding of the past and make us wonder, could another, possibly non-human group have lived on Earth long before us? These strange clues come in many forms. Some are old tools or objects that seem too advanced for their time. Others are huge stone structures that show an amazing level of skill, far beyond what early humans were believed to be able to do. When we take a closer look, some of these discoveries seem to have been made using knowledge or technology that shouldn't have existed yet, at least not according to our current timeline of history. One of the most interesting mysteries is the existence of ancient structures that appear to be built with shocking accuracy. In many places around the world, we find huge stone buildings and monuments that are perfectly lined up with the stars or the sun, something that would have required an impressive understanding of the sky and building skills. But here's the twist. These structures were built thousands of years before modern civilizations were thought to have this kind of knowledge. Take, for example, the massive stone monuments found in places like Egypt, South America, or Southeast Asia. Some of these are not only extremely large, but also built with exact designs that still amaze engineers today. How did ancient people, without modern machines or computers, manage to carve, move, and line up such huge stones so perfectly? Could they have had help, or could they have learned this knowledge from a group that existed long before them? The mystery grows deeper when we find metal objects or materials that seem totally out of place. In some ancient layers of Earth, layers that are tens of thousands or even millions of years old, archaeologists have dug up metal tools, advanced mixes of metals, and even man-made materials that, according to our books, shouldn't have existed back then. In some cases, these materials have strange chemical signs or contain traces of substances that we don't yet fully understand. Could these be leftovers of lost knowledge, or even signs of technological work that goes far beyond anything early humans were able to do? If so, where did that knowledge come from? Then there are the even stranger discoveries. Carved stones marked with symbols that don't match any known language or culture, and tools or objects with no clear use or origin. These items often seem to come from nowhere, showing a level of skill or purpose that doesn't match any ancient culture we know. Some objects appear to have been shaped with great accuracy, or have markings that look more like those made by machine tools than by hand chisels. These mysteries suggest the presence of an intelligence, maybe even a group, that worked with a level of knowledge far ahead of its time. Other strange findings involve structures built in places that seem almost impossible to reach or work in. For example, there are perfectly straight roads stretching over rough mountains and deep valleys, and underground rooms carved into solid rock with no clear entry point or explanation for how they were made. Some of these underground structures are so huge and complex that they confuse modern engineers. Could they have been made by an advanced species, perhaps one that wasn't human, using tools and technologies that we no longer have or understand? All of these discoveries, when looked at together, are like pieces of a puzzle. They don't fit neatly into the story we've been told about human history, that we grew slowly over time, building up our knowledge little by little. Instead, they hint that our past may be far more mysterious, layered, and complex than we ever thought. What if long before the start of written history, a technologically advanced group, maybe even non-human, walked this earth? What if we are only now beginning to uncover their traces, hidden deep beneath layers of time? Mainstream archaeology teaches that modern human civilization began around 10,000 years ago, slowly growing from simple farming communities into complex societies. But the strange and out-of-place objects mentioned above cast serious doubt on that neat timeline. Some of these discoveries, such as tools, carvings, or metals found in ancient rock layers, seem far older than they should be. Others show a level of skill and accuracy that early humans supposedly didn't have. These clues suggest that something is missing from our current understanding, possibly even an entire chapter of history that has been lost. Many of the strangest objects can't be properly dated. Others seem to have been made using advanced machine work or metalworking techniques that shouldn't have been available at the time. Could this mean that some ancient cultures were far more advanced than we think? Or could these be remains of a group that existed long before humans, perhaps even one that we have no record of at all? Some scientists have even proposed bold ideas like the Silurian hypothesis, which asks, what if a smart industrial group lived on Earth millions of years before humans and disappeared without a trace? If this is true, some of the strange items we've found might be their leftovers, left behind like forgotten tools in an ancient workshop. These odd findings don't just challenge our ideas of the past, they also reveal possible weaknesses in our methods. What if the tools we use to uncover history are missing some of the most important clues? What if we've already found signs of lost groups, but pushed them aside because they didn't fit the story we expected? If we open our minds to new possibilities, we might begin to see that the past isn't a straight line. It's more like a maze filled with twists, turns, and secrets still waiting to be uncovered. Some of the world's most famous ancient monuments might hold hidden meanings if we look at them through this idea. Structures like the megalithic stone circles in Europe, the giant stone heads of Easter Island, and the pyramids of Egypt have long confused experts and inspired bold theories. Take Göbekli Tepe, for example, a site in modern-day Turkey believed to be the oldest known megalithic structure in the world, built more than 11,000 years ago. Its tall stone pillars are decorated with carved animals and strange symbols. But what's truly surprising is that it seems to have appeared suddenly in the archaeological record, with no earlier examples to explain its origin. Did this knowledge come from an older group that we no longer remember? Or consider the Nazca lines in Peru, giant drawings carved into the earth, only visible from the sky. How did ancient people make such huge figures without being able to see them from above? Could this point to knowledge of aerial viewing possibly passed down from an older and more advanced group? Even the Egyptian pyramids and the temples of Malta are full of mysteries. Their perfect lineups with stars, their strange internal echoes, and the size of the stones used suggest a type of engineering that may have been far ahead of its time. Some of the world's most mysterious and awe-inspiring ancient structures might offer important clues that challenge what we think we know about history. These giant buildings, often called megastructures, are not like the usual ruins we find from ancient times. They are enormous, incredibly exact, and sometimes seem to have been built with skills or knowledge that don't match the time periods we connect them with. For example, at several ancient sites around the world, massive stone blocks have been carefully fitted together without using any cement. These stones are not only huge but also perfectly lined up, sometimes with the stars or the sun, showing a deep understanding of math and astronomy. Stone circles, huge terraces, and water-carrying systems known as aqueducts seem to show that the people who built them had an advanced grasp of engineering, possibly beyond what we thought was possible for ancient civilizations. What makes these ancient structures even more interesting is the level of planning, skill, and possibly even machines involved in building them. In some places, enormous stones were carved with amazing accuracy and moved across long distances, something that would be very hard to do even today without powerful tools. Some researchers think that the builders may have used advanced materials, like early types of concrete or man-made stone, which seem too modern for the times they came from. These ideas suggest that knowledge or technologies might have existed in the past, but were forgotten over time. In some cases, the way these buildings were made is so strange that it raises even more questions. Multiple layers of different materials, complex shapes, or buildings that don't seem to serve any clear purpose might mean they had symbolic, spiritual, or sky-related meanings. This suggests that the people behind these structures were not only skilled builders, but also had a rich and complicated culture. All of this leads to a bigger mystery. Could there have been earlier groups, possibly even worldwide ones, that were far more advanced than we thought? And if so, what happened to them? Many of these ancient wonders are located in places that are now underground or underwater. These hidden places might hold the answers to questions about groups that came long before our own and then vanished without a trace. That's where the Silurian hypothesis comes in. This is the idea that an advanced group might have lived on Earth millions of years ago, long before modern humans. If such a group did exist, its remains might now be buried under layers of earth or sunk deep under the ocean. Underground and underwater archaeological sites are especially important because they can protect ancient ruins from erosion, theft, and other types of damage. These sites might contain old tools, buildings, or even remains of cities that have been sealed off for thousands or even millions of years. For instance, underground tunnels and buried cities could hold clues about lost technologies, while sunken settlements beneath the sea might show signs of intelligent life that lived during a forgotten chapter of Earth's history. Some researchers think that entire cities may have been swallowed up by rising sea levels or major disasters, leaving behind only ruins hidden below the waves. Discoveries like these could completely change how we see human history, and possibly reveal that intelligent beings lived on Earth long before us. But finding these lost sites isn't easy. Earth is a huge place, and natural processes like earthquakes, landslides, and the slow movement of soil can cover up or destroy evidence. Traditional digging methods can't reach many of these places. That's why scientists now rely on powerful modern tools to help them explore. Two of the most important technologies being used today are ground-penetrating radar, GPR, and LiDAR, short for light detection and ranging. Ground-penetrating radar works by sending radio waves into the ground. When those waves hit something underground, like a buried wall, a hidden tunnel, or even an ancient object, they bounce back. The radar picks up the echoes and creates images of what's below the surface. This helps archaeologists know where to dig and what to look for without having to dig up everything blindly. LiDAR is another amazing tool. It uses laser beams, usually from a drone or airplane, to scan the ground from above. These lasers can see through thick forests and other things that normally hide ancient ruins. By measuring how long it takes for the laser light to bounce back, LiDAR creates detailed 3D maps that show even small changes in the landscape, like old roads, building outlines, or hidden pyramids. Some lost cities have already been found using this technology in places like Central America and Southeast Asia. These high-tech tools allow scientists to explore huge areas quickly, safely, and in great detail, something that would take years to do by hand. They also help researchers compare sites in different countries, uncovering patterns and similarities that might point to a shared worldwide culture that existed long ago. However, even though GPR and LiDAR are incredibly powerful, they come with their own challenges. The amount of data they produce is massive, and understanding it takes skill and experience. Sometimes it's hard to tell the difference between man-made objects and natural formations. And even when something strange is discovered, scientists still need to prove how old it is, who made it, and what it was used for. That brings us to the next big question. Once we find something unusual, how do we know it's real? And how do we figure out how old it is? These are the puzzles that researchers must solve if we are ever to uncover the true story of Earth's ancient past. Could it be that long before modern humans walked the Earth, another intelligent group built wonders that now lie hidden, waiting to be rediscovered? Trying to prove whether strange-looking objects are real and figuring out exactly how old they are is one of the hardest tasks researchers face. This is mainly because today's scientific tools, though powerful, have their limits, and the objects themselves are often mysterious and difficult to study. One major problem is telling the difference between truly ancient items made by intelligent beings and modern copies or naturally formed objects that just look like they were crafted by someone. Sometimes, even rocks shaped by wind or water over thousands or millions of years can look like man-made tools or structures. Scientists use different methods to date objects and determine their origins. Techniques like radiocarbon dating, thermoluminescence, and studying soil layers can offer clues about how old something is or what layer of Earth it came from. But none of these methods are perfect. They rely on certain assumptions, like the idea that specific chemical elements or layers in the soil have stayed the same over time. Unfortunately, environmental conditions, contamination, or movements in the ground can disturb these layers or chemical traces, making the results unclear or even misleading. Things get even more complicated when the object in question doesn't fit into what we currently understand about ancient history. Objects with strange shapes, unusual materials, or unknown building methods are often met with deep doubt. Some scientists might quickly dismiss them as natural rocks or modern fakes. However, unless these conclusions are supported by strong evidence, such as dating from multiple methods, consistent placement in untouched soil layers, or nearby related objects, the answer remains uncertain. The task becomes even more difficult when the object is broken, worn down, or has been affected by natural forces like wind, water, or volcanic activity over tens of thousands or even millions of years. Adding to the difficulty is the simple fact that nature can fool us. The natural world can create shapes that look so much like real tools or decorations that even trained experts can be misled at first sight. Certain rocks break in neat angles, some minerals grow in patterns that look like carvings, and hardened lava can freeze into forms that appear almost like parts of machines. At a quick glance, these natural shapes can easily be mistaken for objects made by human hands. Because of this, scientists have to look very closely and be extremely patient before deciding whether something is truly an artifact or just a trick of nature. To separate real objects from natural lookalikes, researchers rely on knowledge from different fields. Geology helps them understand how Earth's layers, rocks, and pressures shape objects over long periods of time. Mineralogy helps them recognize which minerals grow in certain ways and which ones cannot be carved easily. They also study how natural formations develop slowly over thousands or even millions of years. All of this information helps them judge whether an object was shaped on purpose or simply formed by wind, water, heat, or pressure. Experts often start by examining suspicious objects under strong microscopes that can reveal tiny details the human eye cannot see. They also run chemical tests to learn what the object is made of, whether it contains materials commonly used by ancient people or minerals that formed naturally underground. Three-dimensional scanning adds another layer of evidence, allowing scientists to check the surface for clues. True artifacts usually show signs of careful work, such as straight cuts, repeating lines, smooth and even surfaces, or marks left behind by tools. Natural objects, on the other hand, tend to have rough, uneven or random textures caused by natural forces like erosion from wind or water, the slow growth of crystals, or the crushing pressure deep inside the Earth. One of the most important factors in deciding whether something is real is the place where it was found, its context. If an object is discovered in the same layer of soil as other ancient items such as stone tools, pieces of pottery or bones, then it has a much higher chance of being authentic. This is because everything in that same layer likely belongs to the same period of time. But if the object is found alone, without any related items nearby, or in a place where the soil has been disturbed, scientists must be far more careful before accepting it as genuine. The surrounding geology also plays a major role. Understanding the history of nearby volcanoes, rivers, earthquakes, or rock layers helps experts judge whether the object could have been shaped by nature instead of crafted by someone long ago. Modern technology is making this kind of investigation even more precise. Spectroscopy can identify the materials inside an object and show whether they match the materials used in known human tools. Three-dimensional scanning and powerful electron microscopes can reveal extremely small details, such as tiny scratches left by tool edges or grooves from shaping techniques. These marks are often too small for the naked eye to notice, but they can completely change the case. By combining all these scientific tools, and by bringing together the knowledge of archaeologists, chemists, geologists, and other experts, researchers can form a much clearer idea of what an object really is. With careful study, they can tell whether something was created by ancient hands or formed naturally over countless years, helping us better understand the true story of our past. Climate change and changes in the environment have played a powerful role in shaping the story of human history, and perhaps even the hidden stories of civilizations that came before us. These natural forces act like both protectors and destroyers. Sometimes they help save traces of the past. Other times they wipe the evidence away completely, leaving behind only whispers buried deep in the earth. On the one hand, nature can be an incredible keeper of history. Certain conditions, like fast burial under mud or sand during floods, the cold and airless environment of peat bogs or deep caves, or being sealed in ice or covered by volcanic ash, can protect ancient objects and even human remains for thousands of years. A famous example of this is Ötzi the Iceman, who lived over 5,000 years ago. His body was found frozen in the Alps, perfectly kept by the cold. In other places, entire towns have been covered by ash from volcanic eruptions, freezing them in time and giving us rare, detailed pictures of life in the distant past. But nature can also act as a great eraser. Huge changes like ice ages have dramatically reshaped the Earth. Thick ice sheets can grind down landscapes, crush artifacts, and erase whole coastal settlements as sea levels rise and fall. Glaciers can scoop up or bury ancient remains and move them far from where they were originally left. Volcanic eruptions, while sometimes saving things, can also destroy everything in their path, burning, burying, or scattering what remains of past civilizations, the oceans have their role too. When sea levels rise, entire coastal cities can be swallowed, hiding all evidence underwater. When the sea pulls back, it can reveal sunken lands that were once thriving settlements. These powerful natural events are like a double-edged sword. They can either save ancient secrets for thousands or even millions of years, or they can erase them completely. That's why understanding how the Earth's environment changes is so important to archaeologists and geologists. These forces shape what we can find, what lasts, and how we understand the story of civilizations long gone. This constant push and pull between saving and destruction sets the stage for deeper questions. How have past ice ages, volcanic eruptions, and oceanic shifts shaped our ability to discover forgotten civilizations? Could there be entire chapters of Earth's history missing simply because nature swept them away? Let's look more closely at how some of these forces work. During ice ages, which have happened many times over millions of years, massive sheets of ice stretch across continents. These glaciers can act like natural freezers, saving objects and remains in the frozen ground. But as they move, these glaciers also act like bulldozers, flattening the land, crushing artifacts, and dragging debris over great distances. When the ice finally melts, it can wash away what little is left, or leave evidence mixed and scattered. In some areas, the weight of the ice pushes the ground down and bends the natural layering of soil and rock, making it much harder for scientists to figure out the age and origin of what they find. In places that were not covered by ice, sea levels during ice ages fell dramatically. This revealed land bridges, like the one that once connected Asia to North America across what is now the Bering Strait. These exposed lands made it possible for people, and possibly earlier civilizations, to move across continents. But when the Ice Age ended and sea levels rose again, many of those areas were drowned, possibly taking entire settlements with them. Volcanoes add another layer of mystery. When they erupt, they can quickly bury entire towns and forests in volcanic ash or lava. The ash, called tephra, can cover everything in a thick blanket, freezing a moment in time. This can sometimes save things with incredible detail, almost like a natural time capsule. But future eruptions, earthquakes, or erosion can later disturb or even destroy these delicate layers, scattering the evidence. Volcanic landscapes themselves constantly shift, which makes scientists' efforts to analyze what lies beneath more difficult. The oceans also play a massive role in what we find and what we lose. Over time, sea levels have risen and fallen by hundreds of feet. When the sea rises, it swallows coastlines and floods cities, hiding them under layers of silt and coral. When the sea moves back, it can reveal lost lands, like ancient river valleys or shorelines that once hosted thriving communities. The movement of Earth's crust, through a process called tectonic activity, can lift entire regions out of the sea or cause them to sink, messing with the layers of sediment that archaeologists depend on to date what they find. Altogether, these forces create a constantly changing picture of Earth's surface. Some areas may save ancient clues for tens of thousands of years, while others may bury or destroy them without a trace. This makes the job of finding civilizations that existed before humans, or alongside early humans, a huge challenge. To solve these ancient mysteries, scientists must read Earth's layered history like a detective sifting through a book with missing pages. Some scientists and thinkers have asked, what if natural disasters didn't just shape history, but completely erased parts of it? Could civilizations that existed long before us have been destroyed so suddenly and completely that hardly any trace remains? We know that environmental disasters have caused major collapses in human societies, but for civilizations that may have existed before us, or early in human history, these events could have had even more dramatic effects. Take, for example, the Younger Dryas, a sudden period of strong global cooling that started around 12,900 years ago. This big shift in climate may have devastated early farming communities and forced entire groups to leave their homes. Even earlier, about 74,000 years ago, the Toba supervolcano erupted in what is now Indonesia. That eruption was one of the largest in Earth's history and may have triggered a global volcanic winter. Some scientists believe it caused a massive drop in human population, a bottleneck that could have affected both human evolution and the survival of other possible civilizations. Asteroid impacts are another frightening force. The most famous one happened around 66 million years ago when a huge asteroid hit Earth near the Yucatan Peninsula. This event, known as the Chicxulub impact, is believed to have wiped out the dinosaurs. If an impact like that happened during the time of a prehuman civilization, it could have ended it almost instantly, crushing cities, destroying food sources, and plunging the world into chaos. But not all disasters wipe everything out at once. Some might weaken a civilization slowly, setting off a chain reaction of problems. A drought could lead to failed crops, which might cause conflict, war, or movement. Over time, the society might fall apart, not with a bang, but with a slow breaking down. Two very basic natural processes, sedimentation and erosion, also shape what lasts from the ancient world. Sedimentation is when layers of sand, mud, and organic materials slowly build up over time. In quiet places like lake bottoms or calm river valleys, these layers can gently cover and protect artifacts like tools, bones, or even entire structures. In such calm and stable environments, things can stay saved for tens of thousands of years. Erosion, though often seen as destructive, plays a double role in the world of archaeology. On one hand, it wears away soil and rock over time, which can damage or destroy ancient sites. But on the other hand, it can also be a powerful tool of discovery. As erosion slowly removes layers of earth, it sometimes uncovers objects and structures that had been hidden underground for thousands of years. What was once buried and forgotten can suddenly come to light, giving us exciting looks into the distant past. Places like coastal cliffs, riverbanks, and steep mountain slopes are especially important in this process. These natural landscapes often act like nature's own digging tools. As rain, wind, and water do their work over centuries, they strip away the surface and reveal traces of ancient human life, tools, pottery, bones, and even forgotten homes. In this way, erosion doesn't just destroy history, it also helps us find it. But erosion doesn't work alone. It constantly interacts with another powerful natural force, sedimentation, the slow build-up of materials like mud, sand, and minerals that get deposited over time. These layers can cover and protect ancient remains, or sometimes change the environment around them. When minerals mix with the buried materials, they can help save them by turning them into stone, a process called mineralization. However, not all chemical reactions are helpful. In some cases, the wrong soil conditions can speed up decay. For example, soil that is very acidic can break down wood, bone, and other organic materials much faster. In contrast, soil that is more neutral or slightly alkaline can keep these remains in good condition for thousands of years. Understanding how erosion and sedimentation work is very important for archaeologists. These processes don't just decide whether artifacts survive, they also affect where those artifacts end up and how easy they are to find. When archaeologists learn to read the marks left by erosion and sedimentation, like unusual soil layers, shapes in the landscape, or exposed artifacts, they can better decide where to dig and how to understand what they find. But there's another important factor that can hide or show traces of ancient civilizations: natural resource deposits. These include things like coal layers, underground water, aquifers, and mineral-rich rocks. These deposits can act like both protectors and barriers of history. Sometimes they hide human activity deep underground, and other times they bring it to the surface. For example, when ancient people mined minerals or used natural resources, they often left clues behind. These clues might be changed rock layers, strange shapes in the ground, or leftover materials from metalworking or tool-making. Today, scientists can detect these small signs using advanced tools like geochemical analysis, which helps them see changes in mineral content caused by human activity. In some cases, these resource deposits have actually protected ancient items for thousands of years. Imagine an old mine or a peat bog that kept wood, cloth, or even human bodies so well that they still look nearly untouched today, like nature's time capsules. However, these same deposits can also bury or change archaeological layers over time, making it harder to tell whether a structure or shape is natural or made by humans. Interestingly, areas with many natural resources were often magnets for early human settlements. People were drawn to these places for useful materials, like metal ores or fresh water. But mining and other activities often disturbed or destroyed the very evidence archaeologists now search for. Artifacts might be pushed deeper into the ground or broken. Still, in some special places, like peat bogs or salty, mineral-rich lakes, even fragile materials like fabric or rope can survive for a very long time. All this shows why it's so important for experts in different fields, from geology to chemistry to archaeology, to work together. Only by combining their knowledge can they fully understand how natural deposits affect finding ancient sites. Knowing about geology helps researchers figure out where to dig and how to explain what they find. Sometimes, it even helps them uncover parts of our past that would otherwise stay hidden. To take this search even further, scientists now use a powerful modern tool, climate models. These models help researchers predict where evidence of lost civilizations might be hiding by showing how Earth's climate has changed over tens of thousands of years. By simulating ancient weather, like rain, temperature, and wind, these models can identify areas that once supported human life, but are now covered by deserts, forests, or oceans. For example, a region that is dry and empty today might once have been a green and fertile valley with rivers, crops, and villages. Using paleoclimate data, like ancient pollen, ice cores, and soil layers, scientists can recreate what the world looked like in different periods. This helps archaeologists focus their efforts on places where ancient people likely lived, even if those places are now hidden under sand, soil, or snow. One especially helpful way climate models are used is with satellite images and ground-penetrating radar. These technologies can find signs of human-made structures, like old roads, canals, or cities buried under the ground. When combined with climate models, they give a clearer picture of where and when these structures were built, and why people may have left them behind. These models are not fixed. They get better over time, using new information from biology, geology, and climate science to make more accurate pictures of the past. With these tools, researchers can even find short climate windows, times when the environment was just right for human civilization to grow and thrive. Knowing when and where these windows happened helps archaeologists search smarter, not harder. But the story doesn't stop with the past. In fact, future climate change could open up new possibilities and create serious new problems for archaeology. As global temperatures rise, ice sheets melt, seas rise, and weather changes around the world. These environmental changes are already reshaping Earth's surface, sometimes revealing long-hidden sites, and other times damaging fragile remains. For example, when glaciers melt in places like the Arctic or the Alps, they may uncover amazingly well-preserved ancient settlements, tools, clothing, and even mummies, frozen in time. Yet, once these remains are exposed to air and sunlight, they can start to decay quickly. In other areas, stronger storms and heavier rains may wash away or cover ancient layers, while new patterns of drought and heat may dry out regions that were once rich in plants and water. These changes could help preservation in some dry places, but make digging harder in others. In places like deserts or frozen tundra, once seen as poor spots for archaeology, changing climate conditions may suddenly make them more promising. But they also come with new problems, like salty soil or melting frozen ground, both of which can damage ancient artifacts and make excavation harder. That's why archaeologists today are racing against time. They know climate change is altering Earth in unpredictable ways, and many fragile pieces of human history might soon be lost forever. That's also why it's more important than ever to combine climate science with archaeology, using every tool to find, study, and preserve the past before it disappears. Studying how Earth's environment has changed in the past gives us powerful lessons about how human civilization survived, or sometimes failed, through the centuries. Many ancient societies like the Maya in Central America and the people of ancient Mesopotamia in what is now Iraq faced big challenges like changing weather, running out of resources, and natural disasters. These struggles often led to serious problems for those societies, sometimes even to their collapse or change. These stories show a powerful truth. No civilization, no matter how advanced, is completely safe from nature. One of the most important lessons from the past is the value of being able to adapt. Civilizations that survived tough environmental changes usually found smart ways to adjust. They changed how they farmed, managed water and forests better, or reorganized their societies to handle new challenges. Societies that ignored warning signs, like long droughts or damaged soil, often could not survive. A clear example is the fall of the classic Maya civilization, which seems linked to major climate changes and forest destruction. This shows how environmental stress, combined with poor responses, can push a society toward disaster. Another key lesson is that long-term planning and caring for the environment are essential. Many ancient civilizations didn't have the ability, or sometimes the sense, to plan for the future. They used up resources too quickly, and when trouble came, they were unprepared. This led to social breakdowns and even the disappearance of entire cultures. Today, we see similar problems. Climate change, overuse of fossil fuels, deforestation, and pollution are putting modern societies at serious risk. Studying earlier civilizations reminds us how important it is to build a future based on sustainability and smart planning. Interestingly, not all environmental crises led to disaster. In many cases, hard times pushed people to be more creative. Faced with droughts, floods, or food shortages, ancient people often made new tools, better farming methods, or new religious ideas to understand their world and survive. These moments show the amazing ability of humans to find hope and progress, even when things seem bleak. In the end, looking at how ancient civilizations dealt with environmental changes teaches us that the survival of any society depends on its ability to adapt, plan ahead, and live within nature's limits. This is more than just a lesson from history. It is a warning and a guide for our time. If we want modern civilization to last, we must take care of our planet, think long-term, and be ready to change when needed. As we think about this, a fascinating question comes to mind. What if ancient civilizations also existed long ago and disappeared just like the Maya or Mesopotamians? And how does this connect with the ongoing search for intelligent life beyond Earth, the work of SETI, the search for extraterrestrial intelligence? Could the rise and fall of ancient human or even non-human civilizations help us understand what might be happening on other planets? Trying to find the remains of machines or buildings made by an ancient civilization isn't as simple as digging in the dirt and hoping to find a gear or a metal pipe. Over thousands and thousands of years, most items on the surface either get buried deep underground, worn away by weather, or broken down by time. However, a smart and careful scientist can look for something much harder to destroy. Strange patterns hidden in the Earth's electric and magnetic fields, gravity, and even in the way sound moves through rocks. These hidden clues, though invisible to the eye, may be signs left behind by a long-lost technological world. One of the most exciting kinds of evidence is called an electromagnetic anomaly. This means unusual behavior in the Earth's natural electric or magnetic fields. If an ancient civilization once built machines, power systems, or communication networks, these activities could have left unnatural electromagnetic fingerprints. For example, old underground wires or machines might change how electricity moves through the soil, or create strange magnetic spots that don't match the rocks around them. Today, scientists use tools like magnetometers and electromagnetic scanners to study the Earth's surface. These tools help them spot odd electrical or magnetic patterns. If these anomalies are organized and don't look like natural formations, they might point to something made by humans, like a buried power system or forgotten energy device. Gravity is another tool scientists use. Everything with weight pulls on everything else, even a little. So, if something unusually heavy is hidden underground, like a giant machine, a buried room, or dense material unlike anything else there, that spot will create a tiny but measurable change in gravity. Using sensitive gravity measuring instruments, researchers can map these changes. If they find dense areas underground that don't match the natural rocks of the area, they might be seeing the remains of an ancient energy facility or technological structure. Sometimes, these changes in gravity can even show signs that something below ground has recently moved. Sound waves moving through the Earth can also reveal hidden secrets. When scientists send seismic waves into the ground, usually by creating small vibrations and recording how the waves bounce back, they can detect strange shapes and materials hidden deep below. If the waves bounce off tunnels, chambers, or man-made structures, the patterns look different from waves that hit only natural rock. For example, stone buildings or metal machines underground can reflect seismic waves in unique ways. This allows scientists to create pictures of what's down there, even if it's hundreds of feet below the surface. These reflections may show where ancient engineers built foundations, walls, or complex energy systems. The real breakthrough happens when electromagnetic, gravity, and seismic clues all match up. When strange magnetic fields appear near gravity changes and unusual seismic reflections in the same area, it strongly suggests that something unusual, maybe even made by humans, is buried there. These overlapping clues could be pointing to the remains of an ancient power system, or technology we no longer understand. It raises an important question. What kind of energy might such a civilization have used? If ancient civilizations had energy systems, they might not look like anything we know today. Instead of steel wires and power plants, they may have used the Earth's natural energy with materials and methods now lost to history. For example, if they used geothermal energy, we might find signs of heat that don't match the natural flow underground. These hotspots could suggest artificial heating or ancient drilling. Strange patterns in mineral layers might show that the land was once changed by heat or chemical reactions. Another clue could come from rocks themselves. If a rock has unusual isotopes or contains rare metals, it might mean it was exposed to strong radiation or used in storing energy. Some old stone sites that line up perfectly with the stars or Earth's magnetic field may not just be ceremonial. They could have been part of large energy systems, collecting power from the sun or Earth itself. Even more amazing would be finding objects made of rare or strange materials, things we can't explain with known ancient methods. If we find tools or containers made from advanced alloys, synthetic materials, or other unusual substances, it could mean these objects were part of ancient batteries, power controllers, or energy converters. It's possible that ancient electromagnetic or sound-based energy systems left a lasting mark on the Earth's crust. Over tens of thousands of years, these signals might fade or be buried under newer layers, but some parts might still be detectable. For example, a strange repeating magnetic signal or a faint rhythmic vibration from deep underground could hint at a power system that once hummed with energy. If a highly advanced civilization existed long ago and had a communication network or data storage system, small traces of that technology might still be in the Earth today. These traces wouldn't be the usual things archaeologists look for, like broken pots, carved stones, or rusted tools, but subtle clues buried in soil, rocks, or ice. These could be unusual chemicals, odd patterns in minerals, or strange materials that don't match natural formations. Imagine if this civilization used nanotechnology, tiny machines or particles smaller than a grain of sand. If they used these microscopic tools to store information or send messages, they might have left behind materials unlike anything found naturally. These could include engineered particles, synthetic plastics, or very thin carbon sheets like modern graphene. Over time, such materials could become trapped in layers of rock or mud, lasting thousands or millions of years. To find these ghostly footprints of lost technology, scientists now use very precise tools. One method looks for rare combinations of atoms, called isotopes, that wouldn't normally be together unless made on purpose. For example, some nanomaterials may contain unusual mixes of metals or chemicals that stand out compared to normal Earth rocks. Scientists can detect these clues using advanced machines like mass spectrometers or high-powered microscopes. Some synthetic materials may even leave special fingerprints. For instance, a synthetic polymer or nanostructure might change the rocks around it, causing new minerals to form or reactions that don't usually happen. These changes can show up as odd shapes, textures, or rare crystal forms visible under microscopes. Even after many thousands of years, these formations could silently tell the story of ancient technology. It's also possible that if the ancient civilization sent messages using electromagnetic waves or sound, tiny physical traces of that technology could remain underground. Certain materials might hold faint magnetic or vibrational echoes, especially if designed to do so. These hidden messages might be hard to find, but with the right tools, scientists could detect them. Of course, there are many challenges. Over long periods, natural forces like erosion, earthquakes, and chemical changes can destroy evidence. Modern pollution or industrial waste could also be confused for ancient technology. But scientists are getting better at telling the difference. With new tools like synchrotron radiation, nanoscale imaging, and isotope detection, researchers now have a better chance of uncovering ancient secrets. Nanotechnology and other advanced materials are special because they often include rare elements or complex structures. These don't appear naturally by accident. If used widely, they could leave faint but clear signs in the Earth. These traces might appear in soil layers, old minerals, or ice cores from polar regions. For example, an ancient society could have made nanoparticles with specific atomic arrangements or protective coatings. These features could help them survive over time, staying in rock layers for tens of thousands of years. Sometimes, These materials could even turn into new minerals, forming crystals that don't occur naturally but can be detected by scientists. The real challenge is figuring out which findings were made by intelligent beings and not just natural events. Researchers look for things that don't belong, like odd element ratios, strange crystal shapes, or unusual amounts of rare metals. These clues may be faint or deep underground, so scientists need highly sensitive tools to detect them. It's also necessary to figure out whether these clues are ancient or from modern humans. That's where a strong understanding of Earth's natural chemistry, rocks, and environmental changes becomes essential. Without it, we might mistake something natural for human-made, or the other way around. But there is hope. As research improves, scientists are turning to the most untouched and stable parts of Earth's layers. By studying the oldest and best-preserved parts of Earth's crust, we may find strange markers that hint at a forgotten technological past. This opens up exciting new possibilities, especially when combining high-tech tools with remote sensing from space. Satellite imaging and remote sensing have completely changed the way scientists explore. These tools let researchers scan huge areas of the planet, deserts, jungles, oceans, and mountains, without having to physically go there. From space, satellites can notice small changes in soil color, mineral types, and surface heat. These changes might point to the presence of something made by humans, like buried buildings or old machines. Special cameras on satellites use multispectral and hyperspectral imaging, which can detect differences in light that our eyes cannot see. These differences can show unusual materials or patterns, like straight lines, right angles, or perfect circles, that are rare in nature but common in human-made structures. If scientists find something unusual, they can send teams to explore those spots more closely. Thermal imaging also helps. It can detect leftover heat or cold spots that may indicate energy use from long ago. Sometimes, a patch of ground can still carry a thermal signature even after thousands of years, especially if unusual materials were involved. But satellite data alone is not enough. Earth has many natural features that look artificial, like straight cliffs, polygon-shaped rocks, or oddly shaped lakes. That's why experts carefully study the data using advanced computer programs and machine learning. These programs help separate real anomalies from natural lookalikes. One of the hardest parts of searching for signs of ancient technology, possibly left by forgotten or even pre-human civilizations, is figuring out what is natural and what might be human-made. In other words, how can scientists tell if a strange-looking rock is just a natural mineral shaped over millions of years, or if it is actually part of an old machine or tool? Nature has a way of making complex and beautiful shapes on its own. Over millions of years, heat, pressure, water, and even tiny life forms have shaped rocks and minerals into patterns that sometimes look like they were made by intelligent hands. For example, layered rocks called banded iron formations or fossilized microbial mats called stromatolites can appear as if they were designed. Some mineral veins form repeating patterns, straight lines, or symmetrical shapes that might trick the eye into thinking they are parts of machines or tools. These formations usually form naturally, through slow buildup of minerals from water, movement of sediments over time, or even biological activity. But just because something looks artificial doesn't mean it is. Nature is a master sculptor. It is even more difficult because mineral formations in nature can be very diverse. Their shapes and patterns change depending on the environment they formed in, such as heat, pressure, or chemicals present. Because of this wide range, it is very hard for scientists to make strict rules to separate natural formations from possible artificial ones. On top of that, when looking at the makeup of minerals or the ratios of certain isotopes, versions of elements with different atomic weights, natural and artificial materials can sometimes look very similar. If a long-lost civilization used special minerals or techniques, those materials might now seem completely natural. Even more confusing, nature sometimes makes rare features, like crystal formations or tightly packed mineral balls called concretions, that might look designed. Another big problem is that the tools scientists use today to find possible signs of old technology may not be precise enough. Technologies like satellite imaging, ground-penetrating radar, or spectroscopy, which studies how materials reflect or absorb light, help researchers look below the surface or inside rocks. But many of these methods don't have the detail needed to spot tiny or subtle signs of human work, especially when buried in complex layers of natural geology. Telling a small artificial signal apart from a natural background, requires not just high-tech tools, but also deep knowledge of how the area formed. Often, this background knowledge is missing, especially in remote or ancient regions where earth layers have built up over hundreds of thousands or even millions of years. Overall, the difficulty comes from three main things. First, nature can mimic human designs. Second, natural and artificial materials can look alike. And third, current technology is limited. Solving this mystery will need not just better machines, but also better understanding of how rocks and minerals form naturally. Only then can scientists reliably spot true signs of ancient technology hidden in plain sight. There is hope, though. As technology improves, our chances of detecting long-lost signs of intelligent activity get much better. One promising area is better remote sensing, the science of studying Earth from a distance, usually using satellites or planes. New, sharper satellite images can now detect small oddities on the Earth's surface, changes in shape, heat, or material that might hint at hidden artificial structures. These could include buried walls, strange shapes in soil, or patterns that don't fit with natural geology. High-resolution spectroscopic tools, especially with artificial intelligence and machine learning, can process huge amounts of data and spot unusual mineral mixes or energy readings that probably did not occur naturally. These smart systems can learn the difference between what nature does and what humans might have done. Other advancements are happening in geophysical surveys, ground-penetrating radar, seismic tomography, which uses sound waves to see underground, and even magnetic resonance imaging are becoming more accurate and cheaper. These tools let scientists explore deep underground without digging. They might reveal buried structures, tunnels, or objects hidden for thousands, or even millions, of years. Dating methods are improving too. New versions of mass spectrometry and radiometric dating can now measure the ages of rocks, bones, and other materials more accurately than before. This helps researchers build timelines, when something was made, buried, and whether it fits known history. If certain areas show signs of advanced material use or unusual energy during a time with no known civilization, that would be a huge clue. Artificial intelligence and big data are changing how we search for these clues. By giving computers lots of information about what natural formations usually look like and what artificial ones might look like, scientists can create smart systems that highlight possible artifacts or technology traces hidden in geology. These systems can study geology, chemistry, physics, and more, bringing many clues together into a clear picture. As these technologies improve, so does our ability to explore Earth's deep past. It's possible that buried under soil or locked inside ancient rocks are secrets of civilizations from thousands, tens of thousands, or even millions of years ago. These advancements won't just help us spot faint signs of ancient technology. They could also change how we understand intelligence and civilization itself. Over the years, many fascinating and thought-provoking ideas have been suggested to explore a bold thought that smart civilizations might have existed long before humans ever appeared. These ideas challenge the usual belief that human civilization is the only one that ever existed on Earth, and that we are relatively new in the planet's long and ancient history. Instead, these ideas ask us to imagine a much deeper past, possibly full of lost civilizations, some even more advanced than our own. These ideas come from many different scientific fields, including geology, archaeology, evolutionary biology, and astronomy. By combining knowledge from these areas, researchers create detailed and believable stories of how intelligent life, either on Earth or on other worlds, might have started, grown, and then disappeared without a trace. One of the most well-known ideas is called the Silurian hypothesis. This idea suggests that a technological civilization could have grown on Earth millions of years ago, long before the first humans walked the planet. However, because of how Earth's geology works over long times, with moving continents, erosion, and sediment buildup, nearly all traces of such a civilization could have been erased or buried deep underground. If anything remains, it might be very hard to tell apart from natural features. For example, strange chemical signs, odd patterns in isotopes, unusual mineral layers, or even fossilized machine parts might be hidden in the rocks, but we may overlook them or mistake them for natural processes. Another popular idea is that there may have been many different civilizations over the ages, each one rising to greatness and then collapsing, only to be forgotten by the next. This view suggests that civilizations might not be rare or unique at all. Instead, they could have come and gone across different geological times, wiped out by disasters like volcanic eruptions, asteroid hits, or massive climate changes. These repeated cycles, along with the slow but powerful forces of Earth like moving plates, may have completely erased the evidence of earlier technological societies. Some of these ideas go even further by imagining civilizations beyond Earth, smart beings that may have lived on other planets or moons billions of years ago, long before humans existed. Thanks to studies in astronomy, scientists know that there are many other places in our galaxy where life could have existed. In fact, some planets might have had oceans, warm climates, and protective atmospheres billions of years before Earth was even formed. If life had time to grow on those worlds, it's possible that smart civilizations could have developed and maybe even vanished long ago. When you look at all these ideas together, they stretch our understanding of civilization, time, and life itself. They show us that we need to think on much larger scales, not just thousands or millions of years, but billions of years, and not just Earth, but the entire universe. They also challenge scientists to improve their tools and methods, to search for subtle signs of intelligence, no matter how ancient or hidden. But how do these models actually work? How do they connect all the complicated parts, like planets, living things, and technology? To build these models, scientists use multidisciplinary approaches, meaning they pull together ideas from different scientific fields to understand how civilizations might start, grow, and disappear. First, they look at the planetary conditions that make life possible. This includes things like a stable climate, active geology, and the presence of an atmosphere. They also study how a planet's size, path around its star, and magnetic field can protect it and support life over long times. Then, they look at the biology. This part examines how life starts, grows, and survives challenges. They think about whether certain signs of life, called biosignatures, could still be found today, even after extreme changes like mass extinctions or climate disasters. Life doesn't just respond to a planet's environment, it also changes it. For example, plants and microbes can affect the atmosphere and climate, which in turn shapes the future of life on that world. These feedback loops can either help civilizations grow or push them toward extinction. Finally, they study the technological side. This includes how long civilizations might last, what kind of damage they might do to their environment, and whether anything they leave behind could be found. For example, scientists wonder if we could ever detect ancient pollution in the atmosphere, unusual energy patterns, or structures buried underground. They also think about the chances that a civilization might fall apart because of war, environmental damage, or running out of resources. Some may vanish quickly, leaving very little behind. By bringing all these pieces together, the planetary setting, the biology of life, and the rise and fall of technology, these models create a richer and more complete picture of how civilizations could live and die across the universe. They remind us that life and intelligence don't just depend on one thing, but on many different forces working together, and sometimes against each other, over cosmic times. These ideas change the way we think about habitability, a planet's ability to support life. They show us that habitability isn't simple or permanent. A planet could be perfect for life at one time, and completely dead at another. Instead of thinking of habitability as a yes or no question, these models present it as a story unfolding across time, where the right conditions might appear, disappear, and return again. One major lesson is that many planets might be better for life than we once thought, especially if life is good at recovering after disasters. If civilizations really did exist long ago, their remains might still be hidden in ancient rock layers or scattered across the galaxy. This encourages scientists to look more carefully at the oldest parts of planets and moons, searching for faint signs of forgotten life. These models also challenge the idea that planets follow a simple, straight path in their growth. Instead, they suggest that random and chaotic events, like asteroid hits, supervolcanoes, or huge ice ages, might play a huge role in shaping whether life survives or disappears. Civilizations might rise quickly during peaceful times, only to fall just as fast when disaster strikes. This explains why we may not see any signs of them. They may have come and gone long before we knew how to look. In the end, these models help us understand how deeply connected everything is: the planet itself, the life it supports, and the technology that life might create. They suggest that the universe could be filled with life in many different forms and stages, some already gone, some just beginning, and others possibly far ahead of us. They make us question whether Earth's story is really so special, or just one chapter in a much larger book. These ideas also offer new ways to think about the Fermi paradox, the famous question: if the universe is so big and life is probably common, then where is everybody? The model suggests that maybe advanced civilizations are rare, short-lived, or extremely hard to find. Some might have destroyed themselves, others might have moved far beyond the kind of technology we know, and some might still be waiting to be found, hidden beneath rock, time, or space. One of the most fascinating ideas explored in these theories is how long a civilization can last, what scientists call technological longevity. According to these models, civilizations, whether they exist on Earth or far away in space, might not survive long enough to be noticed by others. They may collapse or slowly decline, not because of wars or invasions, but because of problems they create for themselves. These could include destroying their own environment, falling into social chaos, or simply reaching a point where technology stops improving or slows down. If most civilizations tend to fall apart or fade away before they can send out strong, long-lasting signals into space, that could explain why we don't hear anything from alien worlds. In other words, the famous Fermi paradox, which asks why, in a universe so vast we haven't found signs of intelligent life, might not mean the universe is empty. Instead, it might mean civilizations come and go too quickly to be noticed. They might shine brightly for a while, then disappear before anyone can detect them. These ideas also often mention something called the Great Filter. This is a name for the big obstacles that stop civilizations from reaching a point where they can travel between the stars or send signals across the galaxy. These filters could be huge disasters, either caused by nature or by the civilizations themselves. Imagine supervolcanoes erupting, huge asteroids hitting planets, or global pandemics changing the climate and wiping out entire populations. Events like these could destroy even the most advanced societies, setting them back or erasing them entirely. What makes it even more complex is that such disasters might not happen just once. They could happen in cycles. Civilizations might rise, reach incredible heights, and then fall, only for new ones to appear later. But each one might last only a short time in cosmic terms. That would mean the chances of two civilizations existing at the same time and being able to communicate are incredibly low. Some ideas go even further, suggesting that certain civilizations might choose, either on purpose or by accident, to stay quiet. They might avoid sending signals into space to keep from attracting danger, or they might follow a set of beliefs that tells them not to interfere with other life. This idea adds another layer to the mystery. If many civilizations are choosing to stay quiet and others are destroyed by disasters, then it's no wonder the universe seems so empty. All these ideas together show civilizations as fragile and short-lived. The silence we hear in space might not mean no one is out there. It might mean that civilizations keep rising and falling before they ever get the chance to reach out. This leads to bigger questions. What makes societies grow or fall? Could the same kinds of disasters that affect Earth also have wiped out other civilizations long ago? Many of these ideas focus on natural disasters as turning points in the lives of civilizations. Throughout Earth's history, huge volcanic eruptions, asteroid hits, or sudden changes in climate have reshaped the world. In these theories, such disasters are not just deadly, they are times of change. When a disaster happens, it can destroy whole cities, kill millions of people, and break social systems. Roads collapse, knowledge is lost, and survivors have to start over. But oddly enough, these disasters don't just destroy. Sometimes they make way for something new. A volcanic eruption, for example, might wipe out a civilization but leave behind rich soil that helps new farming communities grow. Climate changes can force people to move to new areas where they adapt and invent new tools or ways of life. So these disasters can be both destroyers and creators, shaping the long path of human or even alien civilizations. How often these disasters happen and how strong they are matters a lot. If big disasters strike too often, civilizations may never get the chance to build something that lasts. If they happen rarely but are very strong, they could explain why some societies vanish suddenly from history. And when these disasters combine with other problems, like running out of resources or civil wars, it becomes very hard for civilizations to survive for long. Another important point is that the remains of ancient civilizations may not last forever. Most traces of past societies are eventually wiped out by nature. Over tens of thousands, or even millions of years, wind and water wear down buildings, earthquakes and land movements bury cities, and oceans rise to swallow entire coastlines. This makes it very hard for archaeologists to find solid proof of ancient civilizations, especially those that may have existed long before humans. This raises an interesting question. Could the reason we've never found clear evidence of a pre-human civilization be because nature destroyed all the clues? If civilizations existed before humans, might their ruins now lie buried deep under the ground or lost beneath the sea? Some scientists and thinkers think this is possible. They suggest these ancient civilizations might have used long-lasting building materials, or even built huge structures underground or underwater, which would be hard to find with today's technology. Others think maybe they used materials or lived in ways that didn't leave obvious signs, so their entire presence could be hidden in rocks, soil layers, or the ocean floor. It's also possible these civilizations were wiped out by disasters, giant volcanic eruptions, asteroid hits, or sudden climate changes that erase nearly all traces of their existence. These events might act like a global reset button, clearing the Earth and making it unlikely that evidence would survive to our time. Some ideas go further and suggest ancient civilizations might have subtly changed the environment using advanced science, like modifying plants or controlling the climate. These changes could leave strange patterns in soil or rock, things scientists today might not recognize as man-made. They could look completely natural, even if they were actually made by intelligent beings long ago. Still, proving any of this is very hard. One of the biggest problems is that we don't have the right tools or methods to spot such faint ancient signs. The geological record, the layers of rock and soil that hold Earth's history, is incomplete. Earthquakes, erosion, and other natural forces constantly shift, break, or erase these layers. Trying to find signs of a civilization from millions of years ago is like trying to find a single grain of sand in a desert. There's also the risk of mistakes. If we find a strange rock formation, how do we know it's not just a natural shape? Could what looks like an ancient tool really be just a coincidence of nature? From a scientific view, studying the possibility of civilizations long before humans is very complicated. These studies involve many fields: geology, climate science, archaeology, and astrophysics, all working together. Each expert brings a piece of the puzzle, but putting those pieces together is very hard. To figure out whether something strange in the rocks is natural or made by intelligent beings, scientists often have to look for indirect signs. These include unusual chemical traces, strange patterns in tiny structures, or odd layers of soil in the ground. But understanding these signs is still a work in progress. The tools and methods for studying them are still being improved, and scientists must be careful not to let personal beliefs affect how they interpret the evidence. This is called confirmation bias, and it's a real danger in this kind of research. Another huge challenge is time. Some of these possible signs could be hundreds of thousands, or even millions, of years old. Dating materials that old is very hard, and knowing what was happening on Earth at that time makes it even more complex. Many dating methods lose accuracy over long times, and events like erosion, earthquakes, or volcanic eruptions could have buried or destroyed important clues. From a philosophical point of view, these ideas are even more mind-bending. They go against our deeply held belief that humans are the first and only advanced civilization on Earth, and that history moves in a straight line from primitive to modern. These theories make us ask deep questions. What counts as real evidence? Can we trust the tools we use to study the past? Could history be far more complex than we imagine? They also make us examine our own biases. One example is anthropocentrism, the idea that humans are the most important and advanced creatures ever. This belief can make it hard to even consider that intelligent life might have existed long before us, or in ways very different from ours. Such biases can close our minds to possibilities worth exploring. Because these ideas are still very uncertain, they often spark debates about what counts as scientific. One rule in science is that a good idea must be testable. You should be able to prove it wrong if the evidence doesn't support it. But when the evidence is very rare, very old, or hard to understand, this becomes a big problem. Still, difficulty doesn't mean we should give up. It shows the importance of careful, honest, and open scientific methods when studying such extraordinary ideas. Looking ahead, future discoveries could completely change how we see these theories. New technologies are opening up exciting possibilities. Underwater exploration with strong sonar, satellite images of hidden structures, and better ways to date ancient materials might reveal things we couldn't see before. For example, if sonar mapping of the ocean floor finds ruins clearly not natural and older than any known human civilization, that would be huge. Or if scientists find a layer full of tools, carvings, or strange chemical traces and can show it's over 1 million years old, it might suggest that another intelligent species once lived on Earth. On the other hand, these same technologies could prove that no such civilization ever existed. If scientists search the ocean floor, deserts, and deep underground areas but find no clear evidence, no ancient cities, no advanced tools, no biological signs of a previous species, it would support the current view that humans are the first civilization to reach this level of development. Even if evidence is missing, it might not mean these civilizations never existed. Earth is always changing. Wind, water, earthquakes, and other forces constantly reshape the surface. Over millions of years, continents have moved, oceans have risen and fallen, and mountains have formed and eroded. These forces could have destroyed almost all traces of ancient activity. But some rare conditions, like volcanic ash covering a site, or deep-sea cold preserving an object, could have helped clues survive, waiting to be found. Environmental factors also make things harder. Suppose scientists find a sudden rise in carbon dioxide or strange particles in ancient air bubbles trapped in ice. That could point to a global event like a huge fire or industrial activity. But it could also be a natural disaster, like a massive volcanic eruption. Understanding the context is everything. The search for intelligent life beyond Earth, what scientists call SETI, short for the search for extraterrestrial intelligence, is not just about trying to talk to aliens living far away in space. It's also about the exciting possibility that alien civilizations may have already been here long ago and left behind clues we've yet to notice. This idea fits with an interesting theory known as the Silurian hypothesis, which suggests that very advanced civilizations might have existed on Earth or elsewhere in the solar system long before humans came along, and they may have left behind signs of their existence that we just haven't seen yet. So, the mission of SETI isn't only about listening for radio signals or laser flashes coming from distant stars. It's growing into something much bigger, like a space treasure hunt. Scientists are now also looking for physical proof, such as strange objects, mysterious buildings, or unusual patterns in space that might hint at intelligent life from millions or even billions of years ago. For many years, traditional SETI work focused mainly on catching electromagnetic signals, like radio waves or flashes of light, that could have been sent on purpose by intelligent beings. But what if those alien civilizations rose and fell long before humans built radios or telescopes? Their broadcasts would have ended ages ago, making it nearly impossible for us to pick them up now. Because of this, researchers are starting to think that the best way to find ancient aliens might not be through signals, but through space archaeology, a kind of archaeology that looks not on Earth, but among the stars. One exciting idea is to carefully check the surfaces of planets and moons in our solar system. If alien civilizations ever lived or visited these worlds, they might have built things or mined materials, and maybe even left behind huge structures. If scientists spot unusual shapes, perfect geometric patterns, or strange heat signs that don't match natural processes, those could be signs of artificial activity. For example, if a planet has odd mineral deposits, or looks like it's been dug into in ways nature can't explain, it might suggest that someone, or something, was working there a very long time ago. But the search doesn't stop at planets and moons. SETI researchers are also looking into the wider space environment for technosignatures, indirect hints of technology. These could be things like strange energy patterns in space, oddly behaving stars, or large objects that might be giant alien machines. One famous idea is the Dyson sphere, a huge structure built around a star to collect its energy. If such a mega structure was ever built, even billions of years ago, it might still be affecting the light or energy coming from that star in ways we can detect. There's even the possibility that artificial satellites or space probes from long-lost civilizations could be drifting quietly through space, maybe even right here in our own solar system. If intelligent life once tried to explore the galaxy, just as we're beginning to do, then bits and pieces of their technology might still be floating around, waiting for us to find them. In short, the modern search for ancient aliens has become a wide-ranging scientific effort. It now includes the study of old signals, space dust, planetary surfaces, strange metals, and even forgotten objects on Earth itself. Scientists are becoming more like space archaeologists, putting together the ancient story of the universe and hunting for the faint clues that might tell us we are not, and never have been, alone. To find signs of these ancient civilizations, scientists need to know what to look for, and how to tell the difference between something natural and something artificial. Unlike loud and clear radio signals we might expect from living alien civilizations, the traces left behind by long-gone societies would likely be faint, hidden, or even worn out. They could be signals buried in the noise of space, or objects that have been damaged or buried over millions of years. One way scientists are searching is by looking for strange radio or laser emissions coming from specific parts of the sky. These could be leftovers from technology that once sent messages, or just the glow of old machines that still give off energy. These emissions wouldn't be strong or obvious. They might come in bursts or be so faint that only the most sensitive tools could notice them. Some might even be hiding among natural space signals like those from pulsars or quasars, making them very tricky to see. Another way is to search for unusual structures on moons, asteroids, or planets. Structures that look like they were built rather than formed by nature. Maybe giant towers, grid-like formations, or mining areas that seem too orderly to be random. Such discoveries could point to intelligent design, perhaps for life support, energy collection, or even scientific testing. These kinds of clues need powerful telescopes and imaging tools to explore far-off places and see what's lying beneath the surface. Scientists also study space dust, meteorites, and ancient rocks that fall to Earth. If these objects contain materials that shouldn't naturally occur, like rare isotopes, strange metals, or unusual mixes of elements, it might mean they were made by intelligent beings. Some of these might have crashed to Earth long ago and could now be buried in ancient rock layers, just waiting to be dug up and checked. And here's an even more amazing idea. What if some alien objects are already on Earth, buried deep within our planet's ancient history? Imagine discovering a tool or structure that looks way too advanced to have been made by any known human civilization. Maybe a metallic object with a perfect shape, or an inscription using symbols that don't match any language we've ever seen. If such objects exist, they might be mistaken as natural, or simply ignored because they don't fit what we expect. To truly notice these clues, scientists must work together across many fields. Geochemists can test the chemical makeup of strange rocks. Materials experts can check objects to see if their construction is too advanced for their supposed age. Archaeologists can study odd carvings or unexplained objects with fresh eyes. These experts must remain open to the possibility that some ancient mysteries could point not just to lost human cultures, but to visitors from far away. The problem is that unusual objects found in ancient sites can be easily misunderstood. People might think they're natural oddities, or modern fakes, especially if there's no clear way to prove how old they are or where they came from. That's why it's so important to carefully test and confirm these findings using the best science available. The idea that objects from other worlds might be hidden within Earth's ancient history is both exciting and mysterious. It invites us to take a fresh look at old archaeological discoveries, especially the ones that seem strange or don't quite make sense. Maybe, just maybe, some of these puzzling finds are more than just unusual human objects. This way of thinking encourages scientists to broaden their point of view. Instead of only using tools from archaeology or history, they now bring in knowledge from space science, biology, and planetary exploration. When these different fields come together, it becomes easier to imagine that Earth's story could be more linked to visitors from space than we ever thought possible. Thinking along these lines naturally leads to a bold question. What if beings from distant planets visited Earth long ago? And what if they left behind clues, some of which we may have already found, but didn't realize for what they really are? This is the heart of ancient alien theories. These theories challenge the usual explanations offered by archaeologists. They suggest that extraterrestrial beings, intelligent life from other worlds, might have played a role in shaping early human societies. Some even believe that these beings helped spark the birth of human civilization itself. From this point of view, researchers are encouraged to take a second look at strange objects, unusual structures, mysterious carvings, and odd symbols. Rather than brushing them off as myths or coincidences, some people argue that they might actually be proof of contact with beings from other worlds. Imagine, for example, carvings that look far too advanced for their time or structures, built in ways that go beyond the known abilities of ancient cultures. Could these be messages from intelligent visitors lost in time? This idea leads scholars to rethink everything. Maybe not all ancient objects were made by humans alone. Perhaps some were influenced or even created by extraterrestrials. When archaeologists come across objects that don't match the tools, knowledge, or culture of the people who supposedly made them, this new line of thinking offers different explanations. It also encourages teamwork across many fields, astronomy, geology, chemistry, and more, so that experts can study these strange finds from every angle. They begin to search for clues in places that archaeologists alone might miss. Could some ancient materials, for example, have come from outer space? This brings us to something fascinating: the idea that space rocks, like meteorites and cosmic dust, might actually carry messages or materials from alien civilizations. Every single day, tiny particles from space fall to Earth. Some are as small as grains of sand, others are large enough to survive entry through the atmosphere and land on the ground. These pieces of space debris are not just leftovers from exploding stars or wandering comets. They might also carry bits of technology, signs of life, or other clues from intelligent beings that once existed far away from our solar system. Meteorites, in particular, are especially interesting. They come from planets, moons, or asteroids that once existed elsewhere in the universe. When these space rocks land on Earth, they often carry strange chemical signs or unusual atomic patterns. Sometimes, scientists find odd microscopic structures inside them, shapes that almost look like tiny machines or tools. This raises an exciting possibility. Could these be parts of ancient alien technology? For example, some meteorites have shown isotopes, forms of elements like nitrogen or helium that are not normally found in nature. These could point to some kind of artificial process, perhaps something designed by intelligent beings. And even though many scientists remain unsure, some of these patterns have no clear explanation, making them worth a closer look. Cosmic dust, though much smaller, is also worth studying. These tiny bits of matter come from comets, asteroids, and even clouds of gas and dust far beyond our solar system. When collected and studied, they sometimes contain complicated organic chemicals, unusual mineral shapes, or traces of materials that don't usually form naturally. Some of these particles might even carry the building blocks of life, or pieces of long-lost alien worlds. With new tools like powerful microscopes, advanced lasers, and very accurate sensors, scientists can now study even the tiniest particles in amazing detail. They can measure the structure of atoms, find unusual mixes of elements, and study patterns that might hint at something made by intelligence. As this research continues, we may one day uncover stories hidden in the stars, stories of civilizations that lived, built, and disappeared long before we existed. But the search for signs of ancient alien life doesn't stop on Earth. Scientists are now looking up at the skies. Modern astronomy gives strong tools to help find possible alien objects across the universe. This includes not only looking at stars and planets through telescopes, but also studying strange behaviors and mysterious signals in space that might hint at something artificial. One example is a star called KIC 8462852, better known as Tabby's star. Astronomers noticed that this star sometimes dims in odd, unpredictable ways. This strange behavior made people wonder if something huge, like a giant artificial structure, might be orbiting the star and blocking its light. Maybe a Dyson sphere, a theoretical huge structure made by an advanced civilization to collect energy from a star. Tools like the Wide Field Infrared Survey Explorer, called WISE, can detect heat given off by these kinds of possible structures. If something huge were collecting energy from a star, it would give off a unique kind of infrared light. So scientists carefully study these infrared patterns, hoping to spot signs of technology too advanced to happen naturally. Radio telescopes, like the ones in the Allen Telescope Array, also help. They search the skies for strange radio signals, especially narrow and repeating ones that might come from intelligent communication instead of random noise from space. Besides looking at stars, researchers also study the surfaces and atmospheres of faraway planets. Using special methods like spectroscopy, they can look for elements and compounds that don't usually appear under normal conditions. If they find something unusual, like a material that needs advanced technology to make, it could be a clue that someone or something changed that world. Even the outer parts of our own solar system offer places to search. Scientists study the Kuiper Belt and the Oort cloud far beyond Neptune. If they notice patterns or arrangements of objects that seem too organized or unnatural, it might be a sign of past alien activity. Telling the difference between natural events in space and signals that might come from intelligent life is one of the hardest puzzles in modern science. The universe is full of powerful energy bursts and strange, short-lived events that can easily look like they were made on purpose, even though they probably weren't. The main reason this is so tricky is that many of the signals we get from space are unclear or mysterious. Take, for example, fast radio bursts, or FRBs. These are very bright flashes of radio waves that last only a tiny fraction of a second. At first, they might seem like messages sent by alien civilizations, but most scientists think they come from natural cosmic events, like two neutron stars crashing into each other, or violent flares from super strong stars called magnetars. To figure out if an FRB is natural or made by intelligence, researchers must carefully study every detail, like the shape of the wave, how long it lasts, how often it happens, and even how the waves are oriented. One big problem is that the universe is very unpredictable. Many signals happen only once. They just appear and never repeat. That makes them hard to study and even harder to call alien or natural. Even regular signals can be tricky. For example, pulsars, which are spinning neutron stars that send out perfectly timed radio pulses, were once thought to be alien signals when first discovered in the 1960s, but we now know they follow well-understood physical laws. On the other hand, signals that don't follow patterns might seem suspicious but still turn out to come from natural processes we just don't understand yet. Another major challenge comes from our own limited technology. Even though radio telescopes and computers are improving every year, they might still not be sharp enough to catch tiny details that would prove a signal is artificial. Plus, Earth is full of noise, radio signals from satellites, mobile phones, and even space junk. These signals can accidentally look like they came from aliens, confusing scientists. To make things even harder, any alien civilization out there might be using a completely different type of technology to communicate, something far beyond what we currently understand. Instead of radio waves, they might use lasers, neutrinos, or another type of signal we haven't learned to detect yet. If that's the case, we might already be missing messages simply because we don't know how to recognize them. So the real challenge isn't just building better tools, it's also about thinking differently. What does an intelligent signal even look like? How do we tell if something is just a strange cosmic event, or a message from another world? As we build better instruments and develop better ideas, scientists are slowly getting closer to telling natural space signals apart from possible signs of alien technology. It's a long, careful process that sits at the edge of astrophysics and the search for extraterrestrial life, known as SETI. Looking ahead, future space missions might uncover even more exciting clues. These missions could find evidence of ancient alien civilizations that once lived far beyond Earth. Thanks to new and better technology, like high-tech spectrometers, robotic probes, and strong remote sensing tools, we are now better than ever at detecting signs of life or technology on other worlds. For example, missions to Europa and Enceladus, two icy moons of Jupiter and Saturn, are getting ready to look under their frozen surfaces, where hidden oceans may contain the building blocks of life. If these missions find things like biosignatures, signs of living organisms, or even technosignatures, traces of past technology, it could mean intelligent beings once lived under the ice of these distant moons. Mars is also an important part of this search. Current missions are exploring old Martian riverbeds and lake beds to look for fossilized microbes, tiny life forms that might have lived billions of years ago. If we find complex organic molecules or other traces of life, it could mean life once existed on Mars, completely separate from life on Earth. That would be a huge discovery. Meanwhile, powerful telescopes are studying planets beyond our solar system, called exoplanets. These telescopes are now good enough to study the atmospheres of faraway planets. Scientists are looking for unusual chemicals, like artificial pollutants or unnatural lights, which could mean a civilization once lived, or is still living there. Even a small clue like this would be a major turning point in human history. Another exciting idea is to look for actual alien objects. These could include huge space structures, weird energy patterns, or strange signals that don't match anything we know. As our technology improves, searching for these kinds of remains becomes less like science fiction and more like real science. Some advanced civilizations may have lived millions or even billions of years ago and left behind leftovers that we can still detect today, floating in space like cosmic ruins. Looking for evidence of civilizations that might have existed long before humans is not just a scientific search, it's also a moral and emotional journey full of hard questions. It makes us think deeply about how we study the past, how we respect other cultures, and how these discoveries could change what people believe about themselves and the world. As scientists dig through layers of rock and old fossils, hoping to find signs of intelligent life that came before us, they carry a heavy responsibility. They aren't just digging in the ground, they're digging into Earth's story itself, and what they find, or think they find, can have powerful effects. One of the biggest worries is about making mistakes. What if scientists find something unusual, like a strange pattern in a rock or a tool-like object, and too quickly say it was made by intelligent beings? If they're wrong, it could confuse people, mislead the public, and hurt trust in science. That's why it's so important to double-check everything, to use clear and honest methods, and to avoid jumping to conclusions just for attention. Another major issue is how these discoveries affect people's beliefs. For hundreds or even thousands of years, many cultures have told stories about how life began and what makes humans special. If researchers find proof that intelligent life existed millions of years before us, it could shake those beliefs. Some people might feel threatened or refuse to accept the discoveries. Others might feel inspired, realizing that humans are just one part of a much older and bigger story. This could lead to new ideas about our place in the universe and help us feel more connected to the Earth and all life on it. But with such discoveries comes the need for respect, especially when it comes to old objects or sacred places. If something is found that might belong to a long-lost civilization, who gets to study it? Who decides where it should be kept, or whether it should be shown to the public? These are sensitive questions, especially for local communities or indigenous groups who may feel a deep spiritual connection to the land or the artifacts. Scientists must always work carefully, listening to others and respecting different cultural values. There is also the danger of greed and misuse. The excitement of finding ancient civilizations might lead some people to dig up sites without permission, or to sell artifacts for money. This can destroy valuable evidence and erase the real story behind it. That's why it's so important to create clear rules and encourage global teamwork to protect these treasures. In short, searching for ancient, possibly pre-human civilizations raises big and complex questions. Researchers must be careful, honest, and respectful. They must protect the past, not just uncover it. After all, these discoveries could change how we see ourselves, not just as humans, but as part of a much longer and richer story that covers all of Earth's history. If scientists one day found real proof that civilizations existed millions of years before humans, it would be one of the biggest discoveries in history. It wouldn't just change science books, it would change how people see themselves and their place in the world. For many centuries, people have believed that humans are the most advanced life forms Earth has ever known. We've told ourselves that we're the top of evolution's ladder. But what if we're not the first? What if other intelligent beings, maybe even high-tech societies, lived on this planet long before us? That idea alone would shake our understanding of history, and maybe even humble us a little. It might also change how we look at religion, myths, and philosophy. Old stories about gods, lost worlds, and great floods might take on new meaning. Maybe those myths are memories of civilizations that really existed long ago. Religious teachings that focus on a single moment of creation might change into new ideas about cycles, life rising and falling again and again on this ever-changing planet. This kind of discovery could also affect how we think about our own future. If other civilizations rose and fell long before us, what happened to them? Did they destroy themselves? Were they wiped out by nature? Could the same thing happen to us? These questions might make us more careful about how we use technology and how we treat the Earth. On a deeper level, it could make us more open-minded. We might start to accept that intelligence and culture don't always look like ours. Civilizations could come in many forms, with different ways of thinking, making things, and living. This could help reduce narrow, human-centered views of progress and success. But then comes a hard question. Should we dig everything up right now, or should we wait and protect these mysterious places until we're more ready? On one side, exploration is what drives science forward. Using tools like deep-sea robots, satellite images, and chemical scanners, scientists can look in places humans can't easily reach, like under the ocean floor, deep inside glaciers, or in remote deserts. These searches might uncover clues that were once invisible, traces of buildings, tools, or strange materials that don't belong in nature. Every new find helps us build a clearer picture of Earth's hidden past. But exploring comes with risks. Sometimes, digging too quickly or without the right tools can ruin a site forever. Once the ground is disturbed, the original story is lost. And if something natural, like a weird-shaped rock, is mistaken for an ancient tool, it could lead to false stories and confusion. When the media gets involved, things can get even worse, with rumours spreading faster than facts. On the other hand, preservation means protecting these sites from damage. It means leaving them untouched so future scientists with better tools and more knowledge can study them more carefully. It also helps prevent misunderstandings and keeps the truth safe from being twisted or used for fame and profit. Most importantly, preservation respects the idea that some places may hold sacred meaning to others, and that we shouldn't rush to uncover things just because we're curious. Misunderstanding or exaggerating evidence about possible ancient civilizations that existed before humans can lead to serious problems, not just mistakes in science, but also confusion in society and even political or cultural tension. At the heart of the issue is something known as confirmation bias, when people only focus on information that supports their own beliefs while ignoring anything that doesn't. This often happens with unclear or incomplete data, which some researchers or storytellers may twist into dramatic tales. As a result, the truth gets lost and both scientists and the public can be misled. When fragile clues, like strange rock formations or odd artifacts, are made to sound more important than they really are, they can create false ideas about history. These misleading ideas may pull attention and money away from real scientific research. Even worse, they can weaken people's trust in science itself. Things get even more complicated when media outlets or online personalities jump in. They often turn uncertain findings into bold headlines, claiming they've found definite proof of lost, advanced civilizations. This kind of exaggeration makes things worse. It spreads confusion, fuels conspiracy theories, and creates unrealistic expectations. Then, when the exaggerated stories fall apart under careful study, people feel disappointed or betrayed, and they may stop trusting scientists altogether. But the impact doesn't stop there. These claims can also stir up deep cultural and political issues. For example, if someone says a forgotten advanced civilization once lived in a particular country or region, it could boost nationalist pride or create tension with other groups. On the other hand, if such evidence is ignored or rejected because it clashes with someone's religious or cultural beliefs, progress in science might be slowed or blocked completely. Some religious groups, for instance, may see the idea of prehuman civilizations as a challenge to their beliefs about divine creation. A person from a Judeo-Christian background, for example, might see a strange fossil or rock formation as a sign from God, not as proof of a forgotten intelligent race. Meanwhile, some indigenous communities may see those same clues as part of old spiritual traditions. In their view, those artifacts could be linked to wise ancestors or mystical beings, making them more open to the idea that humans might not be the first intelligent species on Earth. Cultural stories shape not only how people think, but also how scientific ideas are received. In places where governments control knowledge tightly, or where people don't trust science, unusual discoveries might be quickly dismissed. In contrast, in cultures rich in myths, where stories of lost cities and ancient gods are common, people may be more open to the idea that the Earth has a hidden past full of mystery. These beliefs also affect how research is funded and how scientists talk about their findings. If a discovery threatens someone's core beliefs, it might face pushback or even be hidden. But in communities that see science as a way to deepen spiritual understanding, those same findings might spark curiosity and open dialogue. That's why scientists must be very careful. When they speak about discoveries that could change how we see our past, they carry a great responsibility. They must communicate clearly, avoid exaggerating what they've found, and be honest about what is still unknown. If they present theories as facts too soon, It can cause confusion and mistrust. But hiding strange findings just because they are hard to explain isn't right either. It might block important breakthroughs. The best approach is to make sure every claim goes through careful checking, peer review, and thoughtful discussion before it reaches the public. This helps avoid mistakes and keeps science honest. Researchers also need to think about the wider effects of their work. Imagine if strong evidence appeared showing that a superintelligent species lived on Earth millions of years before humans. That could shake people's understanding of history, challenge national pride, and even upset religious teachings. So scientists must present their discoveries in ways that encourage thoughtful discussion instead of media chaos. It's important that people learn from these discoveries, not fear them. It's extremely important for scientists to work closely with historians, archaeologists, and cultural leaders whenever they interpret new discoveries. When evidence emerges that hints at civilizations older than anything we have ever known, a big question arises: who gets to tell that story? Scientists have to be very careful with their words, especially when dealing with sacred sites or lands that belong to indigenous peoples, so as not to create conflicts between nations or communities. When the time comes to share these incredible discoveries with the world, the goal should never be to shock or scare people. Instead, scientists should aim to educate, spark curiosity, and open minds. They need to use language that is clear, gentle, and inviting. Words that encourage everyone to explore these mysteries together while honouring the cultures, beliefs, and traditions that shape our planet. As we dig deeper into Earth's ancient past, scientists are not just explorers, they are guardians of knowledge. Every step must be taken with care, wisdom, and respect, because they are handling the story of life and civilization itself. One of the biggest questions raised by the discovery of civilizations that may have existed before humans is, who protects this legacy? If ruins or artifacts are found on land controlled by a country or tied to a specific people's history, disagreements are almost inevitable. Throughout history, control over archaeological discoveries has often led to battles over ownership, national pride, and cultural identity. Now imagine finding something even older, evidence of a civilization that lived perhaps 10 million or even hundreds of millions of years ago. Such a discovery could reopen old debates or ignite entirely new ones. Some might claim a direct connection to a superior ancient lineage, while others could feel their culture or beliefs are being threatened. The Silurian hypothesis explores this fascinating idea that an advanced civilization could have existed on Earth long before humans appeared, buried deep in the layers of rock and soil. If any evidence of such a civilization exists, it wouldn't be visible like the ruins of Egypt or Greece. Instead, it could be hidden far underground, locked in stone that has remained untouched for tens of millions, or even hundreds of millions of years. This possibility raises the stakes dramatically. If scientists ever uncover strange artifacts, unusual structures, or patterns that don't fit with our known history, things that hint at intelligent life long before humans, people are unlikely to agree on what it all means. Some countries or cultural groups might say, this is part of our heritage, it belongs to us. Others might argue, no, this discovery belongs to all of humanity. Scientists everywhere should be allowed to study it. And if the discovery is located in a region already disputed by different nations, tensions could escalate quickly. Worse still, if these finds are seen as challenging national pride or a group's sense of cultural identity, emotions could flare even higher. On top of that, money complicates everything. If ancient sites are found in areas rich in natural resources, like oil, rare minerals, or fossil fuels, companies might rush to exploit them for profit. Others could see these sites as future tourist attractions, hoping to turn history into a business. This creates a difficult choice. Should we protect these discoveries for their scientific and cultural importance, or allow them to be used for financial gain? Without clear, agreed-upon rules, this tug-of-war between conservation and profit could destroy priceless pieces of our past. To prevent conflicts and preserve the true value of these discoveries, we need clear and fair rules that everyone respects. These rules should encourage cooperation, openness, and mutual respect. Some good examples already exist, like the UNESCO World Heritage Agreements, which encourage countries to share responsibility for protecting important cultural and historical sites. We can build on these ideas. Involving local communities, scientists from around the world, and governments can help create trust, ensuring no one feels left out. This way, the pursuit of knowledge can move forward without harming cultures, lands, or the legacy of civilizations long forgotten. For a long time, scientists have believed that the story of life on Earth is mostly a straight line, from simple creatures in the oceans to apes, and finally to modern humans. We've built this story on things like fossils, old tools, DNA, and the ruins of lost cities. It tells a neat, simple tale of humans slowly becoming more advanced over millions of years. But what if that story isn't the whole truth? If we were to find signs of an ancient civilization that existed millions, or even hundreds of millions of years ago, long before humans appeared, everything would change. It would mean humans might not be the first smart beings to build cities, make tools, or form complex societies. That possibility would shake our understanding of history to its very core. Such a discovery would make us ask hard and exciting questions. Are we really unique, or just the latest in a long line of smart species? Have other civilizations grown powerful, only to fall and disappear without a trace? If so, why did they vanish? Did they destroy themselves? Were they wiped out by natural disasters? Or did they just fade away, their knowledge lost under layers of rock and time? This would challenge one of humanity's most cherished beliefs, that we are the top of evolution and progress. It would push us to think about intelligence, not as something only we have, but as something that might have appeared many times before. Maybe there were others who understood the world in ways we can't even imagine. Were they more advanced than us? Did they have technologies we've never dreamed of? Or did they live in harmony with the Earth in ways that made them wise but left little evidence behind? If we are not the first smart species on Earth, then maybe our journey isn't as special or as safe as we thought. It would show that even highly intelligent life is fragile. Civilizations can rise, build wonders, and then fall, becoming buried under millions of years of history. This idea would give us a new view of our own future. If it happened before, could it happen again? Could we be forgotten, just like they were? It might also make us more humble. Instead of seeing ourselves as the only smart life to ever exist, we might start seeing ourselves as part of a much bigger story, a story that stretches across countless ages and includes many forms of life and awareness. The effects wouldn't just stay in science, they would spread into our cultures, religions and philosophies. Many religions and beliefs teach that humans are special, even chosen. But what happens if we're not the first? Would people lose faith? Would stories need to be rewritten? Or would we find new meaning in being part of a greater, more mysterious universe? Some old myths already speak of lost civilizations, Atlantis, Lemuria, and others. These stories might take on new importance. What if they weren't just legends but faint memories of something real? This shift in thinking might also bring people closer together. Instead of dividing ourselves by race, nation, or culture, we might begin to see all humans as one family, one chapter in a much longer story of intelligence on Earth. We might even feel a connection to those ancient beings, whether they were like us or very different. If ancient civilizations rose and fell before us, they might have left behind not only clues but warnings. Maybe they face the same problems we do: climate change, war, resource shortages, or uncontrolled technology. Their fate could help us understand the dangers we face today. Could it be that every smart species faces a moment where it must choose between destruction and survival? If so, learning from the past might be key to building a better future. This discovery might also make us rethink what true progress means. Is it just about more technology, more power, and faster growth? Or is it about balance, wisdom, and long-term survival? Looking for evidence of ancient pre-human civilizations isn't just an exciting idea, it's also full of moral challenges. Digging deep into Earth's rocks and fossils could harm fragile environments or destroy the very clues we're trying to find. Scientists would need to be very careful. Every layer of rock, every fossil is like a page in Earth's diary. If we remove those pages too quickly, we might lose the story forever. And if we do find something amazing, how should we share it with the world? Should we release everything right away, or take time to check, double-check, and think through the consequences? The discovery could shock people, challenge their beliefs, or even cause fear. That's why communication must be responsible, honest, and respectful of different cultures and views. The idea that humans are not alone in Earth's long history isn't just a mystery, it's a doorway to incredible possibilities. It could inspire new ways of thinking, new kinds of science, and a deeper sense of wonder about life, time, and the universe. One of the hardest and most interesting parts of exploring ancient civilizations, especially ones that may have existed long before humans, is how such discoveries could affect world politics. If we ever find strong proof that an advanced civilization once thrived on Earth tens or even hundreds of millions of years ago, it could shake the beliefs and stories that many countries hold dear. Some nations might feel their history is being challenged or even rewritten. Others might try to claim the discoveries to boost their power or support certain ideas. This is why it's very important to make sure the research is done fairly, openly, and with cooperation from scientists and governments around the world. The evidence must be checked by other experts to make sure it's correct. International rules should protect archaeological sites, and the rights of countries over their own land must be respected. Only through global teamwork can we avoid disputes and make sure such amazing discoveries are handled carefully and honestly. But it's not just about politics. If we really find signs of ancient civilizations, especially ones that existed long before humans, we also need to think deeply about what it means for the future. What parts of these discoveries should we preserve? How should we interpret evidence that isn't very clear? Should everything be made public, or are some things too sensitive to share right away? These are moral questions, and they don't have simple answers. Scientists will need to walk a fine line, searching for the truth while being careful about how their findings affect the world. They must think about the environment, society, and the legacy they leave for future generations. As technology improves, these moral challenges will become even more important. The future of this kind of research depends not just on better tools but also on wiser choices. Looking ahead, future scientific discoveries could completely change our ability to find and understand evidence from Earth's extremely distant past. New tools are being made that can look deeper into the ground and detect even the smallest signs that something unusual happened long ago. For example, scientists are improving high-resolution isotope analysis, a method that looks at chemical traces in rocks and soil. This might one day show strange patterns that suggest industry or technology, even if it happened millions of years ago and has since been buried or erased by nature. Other exciting advances include better microscopes and powerful methods like synchrotron radiation imaging. These tools might let scientists find tiny bits of material, like special ceramics, rare metals, or man-made mixtures that could not have formed naturally. If found, they could be silent witnesses of a lost civilization. New scientific fields like astrochronology and advanced geophysical imaging are also becoming important. These methods help scientists understand the timeline of Earth's geological history. Better seismic imaging combined with artificial intelligence could uncover hidden underground structures or objects that don't fit with what we currently know about Earth's development. In places once thought too harsh or empty for life, we might find proof that something smart was once there. Even more, as computers get faster and smarter, scientists can study huge amounts of data more effectively. This will make it easier to spot patterns that were invisible before, like unusual spreads of certain elements across the planet that might point to old industrial activity. When we combine this information with climate models and data from ancient environments, we get a more complete picture of how early civilizations might have lived, grown, and interacted with their surroundings. All these new tools won't just help us find more things, they'll help us better understand what we find. Being able to date objects precisely or match them to events in Earth's past will make it easier to tell the difference between what is natural and what might be man-made. Slowly, what once sounded like science fiction could become real science. Instead of guessing, we may finally build true stories based on solid evidence about Earth's mysterious and ancient past. To make real progress in this search, we can't rely on just one branch of science. We need experts from many different fields working together. This is especially true for bold ideas like the Silurian hypothesis, which suggests that smart civilizations might have existed on Earth millions of years before humans and left only faint clues behind. Geologists and paleontologists bring essential knowledge. They study ancient layers of rock, chemical traces, and fossils that may hold evidence of past technology or sudden environmental changes. Archaeologists use modern tools like ground-penetrating radar or satellite images to search for unusual objects or patterns buried deep in the ground. Climatologists help us understand how ancient changes in the weather could have affected early societies, while astrophysicists study the effects of events in space, like asteroid hits or solar storms, that could have left marks in the Earth's surface. Even geneticists have a part to play by studying ancient DNA to track biological changes that might be linked to intelligent societies, such as the selective growing of plants or animals. Working together, scientists from different areas can create better tools and clearer ideas. By combining methods, like chemical tests with climate models, they can more easily tell the difference between what nature did and what was made by intelligent beings. These partnerships open up new ways of thinking and help question old ideas. With so many points of view coming together, the chance of missing something important is much lower. In short, research across many fields is like putting together a giant puzzle. Each scientist adds a different piece, helping us slowly see the full picture of Earth's mysterious past. It also makes the final results stronger and harder to argue against. If we really want to find proof of ancient civilizations, teamwork across many areas is not just helpful, it is necessary. If it is ever proven that Earth had advanced civilizations long ago, it would completely change how we care for and protect our planet. It would show us that complex life and intelligent societies are not new, and that our Earth might be much more active and fragile than we ever thought. Instead of only focusing on saving the forests and oceans we see today, we would also need to protect the deep layers of the Earth that hold valuable records of our ancient past. One of the first changes would be an urgent effort to save geological records, layers of rock, fossils and soil that might still have traces of these ancient civilizations. These records are like nature's library, and once destroyed, their knowledge is lost forever. New tools would be developed to monitor these sites carefully and protect them from pollution, mining or construction. Knowing that past civilizations may have changed the Earth's environment in big ways could also change how we see climate and nature. It might show us that Earth can recover from huge disasters, or it might show us just how easily it can be damaged forever. Either way, the lesson would be clear. We must treat our planet carefully, and we should learn from the mistakes or successes of those who lived before us. This new knowledge could also inspire countries to work together and agree on rules to protect Earth's history, like how nations today have agreements about exploring space. These shared efforts would help prevent careless actions that could destroy important archaeological or geological sites. More money would likely go into research that connects geology, climate science, and archaeology, so we can better understand how past civilizations lived and what we can learn from them. However, proving that such civilizations existed would also increase our sense of duty to the planet. Looking for signs of ancient civilizations that may have existed long before humans is a very hard task. It brings huge scientific and technical challenges. Unlike human history, where we can often find buildings, tools, or bones that are only a few thousand years old, clues to pre-human civilizations, especially ones that may have lived hundreds of millions of years ago, are probably buried deep underground, broken apart, or completely erased by natural forces. One of the biggest problems is how Earth works. The surface of our planet is always changing because of earthquakes, volcanic eruptions, erosion from wind and water, and the slow but constant movement of tectonic plates. These processes can destroy or hide any evidence that once existed. Old rocks are melted down and formed into new ones. Mountains rise and fall, oceans move. If any advanced civilization ever lived long ago, their cities or tools could have been swallowed by the earth or ground into dust. Even the clues we can search for, like unusual chemical signs, strange ratios of isotopes or rare materials, are often very hard to find. For example, if an ancient civilization used metals or made synthetic materials, those traces might now look almost exactly like something formed naturally. That makes it hard for scientists to know whether something was made by intelligent beings or just by nature. To even try finding such faint clues, we need advanced tools. Scientists use methods like high-resolution light analysis, deep earth drilling, and isotope studies. But these tools have limits. Drilling deep into the Earth is very expensive, and we can only search small areas. Earth's surface is huge, and most of it remains unexplored at these depths. Another problem is time. Earth is about 4,500 million years old. That's such a long time that whole continents have disappeared and formed again. Any evidence from civilizations that lived hundreds of millions of years ago would have gone through extreme pressure, heat, and chemical changes. Over time, even strong materials like metal break down, and many signs would simply be erased or changed beyond recognition. The deeper we look into Earth's past, the fuzzier the picture becomes. Rocks from billions of years ago are rare, and the records they hold are often incomplete. Layers of soil can be worn away or destroyed. Some may have been pushed deep into the planet by tectonic forces, while others might be missing completely. This makes it extremely hard to build a clear timeline or understand what might have happened. Even if ancient civilizations left behind machines, buildings, or other objects, chances are high that these items would be broken into tiny pieces, buried, or chemically changed until they're almost impossible to identify. For example, if a machine was made from a metal that reacts with water or air, it might have rusted away completely. Its remains could now be nothing more than a few specks of mineral dust. Chemical processes also help erase clues. Water that moves through underground rocks can carry away or dissolve important chemical signs. Over time, materials left by a civilization might blend into their surroundings so well that they can't be told apart from natural rocks. Even life activity, like plants growing or animals digging through the ground, can disturb and destroy evidence. Microorganisms can eat organic materials like wood or fabric. Unless something is buried quickly in the right conditions, like a place with no oxygen, it probably won't survive millions of years. The Earth's layers of rock and soil, the sedimentary record, are like a book that's missing most of its pages. What remains is scattered and uneven. That means if a civilization once lived in a place that hasn't been preserved well, all evidence of them may be lost forever. Another issue is that we humans often think of ourselves as the only or most important intelligent beings to ever exist. This way of thinking can blind scientists to the possibility that a non-human civilization may have once existed. If we only look for signs that match what we expect, like metal tools or familiar buildings, we might completely miss very different forms of technology. Some scientists also assume intelligent life is very rare. Because of this, they might not take the idea of ancient civilizations seriously, or might avoid funding research into it. Others may unconsciously ignore strange findings that don't fit accepted ideas, a tendency known as confirmation bias. Even the best scientific tools have their limits. Scientists often use methods like uranium lead or potassium argon dating to figure out how old rocks are. These techniques work really well for ancient minerals, sometimes billions of years old, but they are not always helpful when we're trying to detect signs of advanced technology. Even methods like thermoluminescence, which can tell us the last time a mineral was heated, can be thrown off by natural events, such as wildfires or volcanic eruptions, making the results uncertain. Our most powerful instruments, microscopes that reveal the tiniest details, spectrometers that identify the elements in a sample, and isotope scanners that trace atomic variations, can only go so far. They might overlook tiny traces or clues hidden deep underground. They can also be affected by contamination, or confused when natural processes imitate human-made materials. Because of all these challenges, even if scientists find something unusual in very old rocks, like a strange metal, chemical, or structure, it can be almost impossible to prove whether it came from a long-lost civilization or was created entirely by nature. This is why collaboration between different types of scientists is so important. Geologists, chemists, archaeologists, paleontologists, and even astrophysicists need to work together. By combining their knowledge, they can better detect, understand, and confirm possible evidence. For example, a geologist might notice a strange layer in ancient rock. A chemist could study its composition. An archaeologist might consider whether it relates to tools or structures. An astrophysicist could explore whether a cosmic event, like a meteor hitting Earth, explains the anomaly. Modern technology is helping in exciting ways. Satellites allow us to scan the Earth from space to spot unusual patterns in the landscape. Machine learning can comb through massive amounts of data to uncover hidden clues. Advanced scanning techniques, such as synchrotron radiation or deep core drilling, let scientists see deeper into the Earth than ever before. These tools have already sharpened our understanding of Earth's history and may one day reveal unexpected traces of ancient intelligent life. Researchers now look for unusual isotopes, synthetic elements, strange structures, nanoscale materials, or radiation patterns that could suggest industrial activity or energy use in the distant past. Even if humanity never discovers clear proof of civilizations before our own, the search itself expands the limits of knowledge. It teaches us more about the history of our planet, the possibilities of life and technology, and ultimately our place in the universe. Fossils are like time capsules buried in stone, precious records that give us a peek into Earth's very ancient past. They help scientists piece together the story of life on our planet, showing how living things have changed and grown over millions, even billions of years. Usually fossils are thought to be the remains of once living creatures, plants, animals, or tiny microbes. But sometimes, strange and puzzling fossils are found that don't fit this idea. These rare finds raise exciting questions. Could some of these unusual fossils point to something besides life, maybe the remains of ancient technology, or even lost civilizations that existed before humans? One especially curious group of fossil finds includes unusual mineral shapes and tiny structures that are very hard to explain through normal biological processes. Sometimes, researchers have found fossilized shapes that look incredibly exact and geometric, symmetrical patterns and complex structures rarely seen in nature. For example, some tiny structures buried in rock look almost like they were carefully made, with repeating patterns and shapes that look more like machine parts than parts of living organisms. Some even have detailed, repeating, tree-like, or fractal designs, which are not common in known fossils. Even more surprising are tiny bits of metal or carbon found inside layers of ancient rock that look like man-made objects. Some of these pieces have smooth, even surfaces layered designs, or look like tiny assemblies of parts. These features are hard to explain with what we know about fossil formation. In fact, if we find fossil-like objects with fine grooves, perfect circles, sharp edges, or tiny holes that seem made with tools, especially if they're found next to normal biological fossils, it makes us wonder, were these made by someone or something intelligent? Another interesting area scientists are exploring involves strange chemical and elemental clues trapped inside rocks. For example, some fossils contain elements or metal combinations that don't normally form naturally. Some materials look like they've been heated or changed in ways that suggest they went through some kind of industrial process. These chemical signs might point to artificial origins, especially if found together with the geometric or unusual structures mentioned earlier. Sometimes, researchers even find marks carved or scratched onto fossilized shells or bones, marks that are too exact and regular to be caused by nature alone. When these engravings look like symbols, patterns, or designs, they could hint at tools, craftsmanship, or perhaps machines. This opens a whole new way of thinking about Earth's history. What if, long before humans appeared, other intelligent beings walked this planet? Of course, most fossils show clear signs of life, like shells, bones, or the shapes of leaves and roots. But sometimes, scientists find something that stands out, something that seems different, as if it doesn't belong. These unusual fossils may hold hints that intelligent design or technology once existed on Earth in the very distant past. One possible clue is mineral structures that look like man-made parts. These might include repeating patterns like circuits, layered designs like artificial materials, or tiny lines and shapes that suggest machines. Some researchers have found tiny cracks that seem to follow exact directions, and metals that look mixed or engineered, not natural. In rare cases, fossils even seem to include structures like tiny electronic circuits, which is hard to explain using only biology or geology. Another area of study looks at fossils from microbial mats, or ancient slimy layers left by colonies of tiny organisms. If these structures are in neat layers, with clear symmetry or signs of organization, they might point to something more than just natural microbial growth. Some fossilized mats even have strange chemical signals, like unusual combinations of elements or unnatural isotopes, which might hint at non-biological materials. This could support the idea that something artificial was involved. But there's a big problem. How do we tell the difference between a real anomaly and a natural oddity? Sometimes fossilization itself changes the shape or chemistry of a fossil, making it look stranger than it really is. That's why scientists now use powerful tools to study these mysteries. Advanced microscopes, special scanners, and chemical tests allow researchers to zoom in on fossils at microscopic or even nanoscale levels, showing details too small to see with the naked eye. If any features clearly don't match what nature would produce, it could be a strong sign of ancient technology or intelligent activity. All of this leads to a bigger question. Could these tiny fossil clues, especially the ones too small to see without powerful tools, actually show signs of advanced life or even technology? The study of microfossils, fossils smaller than a millionth of a meter, is fascinating. These tiny remains can be found in rocks that are thousands, millions, or even billions of years old. Microfossils have helped scientists learn about the earliest forms of life, long before plants and animals appeared. Traditionally, these fossils were thought to represent very simple life like bacteria or algae, but recent discoveries suggest that even these early organisms might have behaved in more complex ways than we thought. For example, some microfossils appear to have organized shapes, with cells that seem to work together or form networks, like early versions of biofilms or microbial communities. This could mean even the simplest life forms were already developing ways to cooperate, share resources, or communicate, traits we usually associate with more advanced life. Chemical studies of microfossils have also found surprising results. By measuring the types of carbon or sulfur trapped inside them, scientists can sometimes tell what kind of metabolism the ancient microbes used. Some of these ratios match those seen in modern microbes living in extreme environments, like those doing photosynthesis or surviving high heat or acidity. This suggests early life may not have been so simple. It might have included a range of clever behaviors and adaptations we're only beginning to understand. Some researchers even think certain microfossils might show signs of ancient technology or artificial influence. For example, if a fossil has metal, layered materials, or tiny structures that look like tools or circuits, it could mean early microbes were interacting with their environment in ways similar to engineering. While still debated, these ideas encourage scientists to look more closely at the tiniest traces of the past. The discovery of ancient life, whether simple microbes or more complex organisms, opens an exciting window into Earth's distant past. It helps scientists understand how life may have started and how it slowly changed and evolved over billions of years. But these discoveries also bring puzzles. Figuring out what these fossils really are and where they came from is not always easy. Sometimes it's like solving a mystery with only half the clues. Some of the oldest traces of life come from fossils of microscopic organisms, preserved in rocks as tiny mineral threads or in layered structures called stromatolites. These ancient formations are among the earliest signs of life, and some may be over 3,500,000,000 years old. That means life may have appeared not long after Earth itself formed. But because these fossils are so small and simple, scientists often struggle to tell whether they are truly from living things or just patterns made by non-living processes. For example, certain minerals can form shapes that look like tiny colonies of microbes, making it hard to be sure if they were alive. The problem gets even harder when we look at fossils of more advanced creatures, like soft-bodied animals or early multicelled life. These fossils may have complex shapes and fine details, suggesting life was already advanced early in Earth's history. But interpreting these fossils is tricky. Over time, the way organisms decay and how their remains are preserved in rock can change their appearance. This process, called taphonomy, makes it hard to tell what the original creature looked like, or even if it was alive at all. Sometimes, what looks like a fossil may be a mineral formation that just happens to look lifelike. Another key part of the puzzle is the rock layer, or stratum, where a fossil is found. Scientists study layers of sediment to understand a fossil's age and origin. But this can be misleading. Mineral-rich water can move through rock and leave deposits that form patterns similar to living things. These purely natural formations can look a lot like fossils, so researchers must be very careful. They may not always be what they seem. To solve these mysteries, scientists use very careful methods. They use high-powered microscopes, chemical tests, and isotope analysis, looking at types of atoms in a sample, to find signs of life, clues that a sample came from a living organism. These clues might include certain molecules or unusual ratios of atoms hard to form without life. Even with all this technology, false positives are possible, samples that look like life but aren't. That's why experts from many fields work together to study these ancient traces. They don't just examine the fossils, they also look at the bigger picture, where they were found, how they formed, and what they could mean. But what if some fossils aren't just signs of life? What if they point to something much more advanced? What if, hidden deep in rock layers, there are clues showing civilizations that lived long before humans? This idea brings an even bigger challenge. Some scientists have wondered if certain unusual fossil structures could actually be ancient tools, machines, or parts of advanced technology. But telling the difference between natural mineral formations and artificial objects from deep time is very hard. Many natural processes, like crystal growth, pressure, or chemical changes, can create shapes that look like artifacts. For example, some round stone formations or fossilized microbial films can look very much like carved surfaces, gears, or machine parts. One of the biggest problems is that nature itself can be very good at making patterns and shapes that look designed. Crystals, for example, can grow in perfect geometric shapes, with straight lines and sharp corners. These shapes can easily be mistaken for marks made by tools or machine parts. Even colonies of tiny living things, when turned into fossils, can make repeating patterns that look like they were made by intelligent hands. That's why scientists must use many different kinds of study, like super detailed imaging, chemical tests, and microscopic checks, to understand what they are really seeing. There's another big problem too: time. If a civilization existed hundreds of millions, or even billions, of years ago, then whatever it left behind would probably be buried very deep, worn away, or changed so much that it's hard to recognize. Over such long periods, even strong materials like metal or stone can be broken down, crushed, or changed by heat and pressure. Without clear signs like tool marks, carvings, or groups of objects that clearly don't belong, it's almost impossible to tell if a strange formation in the rock is natural or not. Adding to the confusion, Earth still has many geological mysteries. Some rock formations and structures we find today don't fit into current scientific explanations. These unexplained formations could simply be rare natural events, but they might also be something more. That's why scientists are advised to be careful but open-minded, using every tool available to study these mysteries. They look closely at the shapes, materials, and surroundings of each find, asking whether it really came from nature or from a long-lost hand. This idea leads to an exciting question. Could there be fossilized remains of ancient machines, tools, or technology buried in the earth? Although this idea is very controversial, it isn't completely impossible. Some fossil-like objects found in sedimentary rocks have caused debate because they show patterns that are symmetrical, precise, and complex, features we usually associate with tools or machines. In some cases, scientists have even found tiny metal-like pieces inside fossils that, under a microscope, seem to have patterns like gear teeth, hinges, or other machine parts. If any of these features were proven to be real artifacts, it would change everything we know about Earth's history and humanity's place in it. But before jumping to conclusions, scientists must consider simpler explanations. Many of these shapes can still be explained by natural processes, like the way minerals grow and settle over time. Some silicate crystals, for example, naturally form in shapes that can look like screws, bolts, or parts of a machine, and over millions of years even real metal would likely corrode or be replaced by minerals, making it harder to identify. Context is also very important. A single strange object found by itself doesn't prove anything. But if similar objects were found at multiple sites, with signs of advanced activity like worked surfaces, careful arrangement, or unnatural materials, the case would become much stronger. So far, however, no such discovery has been confirmed for sure. This brings us to the heart of the mystery. Could the fossil record, the big archive of life on Earth, contain hints not just of plants and animals, but of civilizations that lived and disappeared long before us? The fossil record is one of the most important tools scientists use to study Earth's ancient history. It gives us a way to look far back in time, millions and even billions of years, to understand how life has changed and developed. But when scientists try to use the fossil record to look for signs of civilizations that may have existed long before humans, they run into many problems. Some clues might support the idea of such civilizations, but many others raise doubts or are too unclear to prove anything. Fossils usually form when hard parts of living things, like bones, shells, or teeth, are buried and preserved over time. But this process is very selective. It does not preserve everything. Soft materials like wood, fabric, or even the remains of tools rarely survive long enough to become fossils. That means if an ancient civilization left behind things made of soft materials or delicate machines, those items would almost never be found as fossils today. This makes it much harder for scientists to detect signs of complex, possibly advanced societies that may have lived before humans. Even when strange finds appear, like odd-shaped formations in rocks or layers of minerals that don't fit normal patterns, they're often explained as natural, not man-made. Many scientists are careful and tend to dismiss these discoveries if they look like things nature could have made on its own. Some unusual mineral patterns or strange arrangements of sediments might actually be clues, but they are often too subtle for our current tools to see. And without clear, solid artifacts like tools, buildings, or writings, it is very hard to prove these are the work of intelligent beings. On the other hand, the fossil record does give a few curious hints that could support the idea of pre-human civilizations. For example, the sudden appearance of certain minerals or the presence of tiny unexpected fossils, called microfossils, in some rock layers might point to big changes in the environment. These changes could have been caused by advanced life forms doing things like mining, building cities, or using energy on a large scale. But these signs are unclear. It's hard to tell if they came from natural events, like volcanoes or climate changes, or from intelligent beings doing something on purpose. In general, while the fossil record gives us amazing snapshots of life's long journey on Earth, it doesn't clearly support the idea of advanced civilizations before humans. There are no clear, well-preserved signs of such societies, and the lack of strong evidence shows how important it is to improve the ways we search. If we want to find subtle or hidden signs of ancient intelligence, we need better tools and new ideas. This makes us wonder, what new methods could help us look deeper into the past and possibly find signs of civilizations we've never known? Fortunately, scientists are now developing exciting new tools that may help us find what has long been hidden. Traditional fossil hunting methods often rely on what can be seen on the surface, or dug up in shallow layers. But modern techniques go much further than that. One strong method is called ground penetrating radar, or GPR. When used with special three-dimensional imaging, it lets scientists see what's underground without digging. These tools can find buried structures or shapes that might be old buildings or roads, even if they're covered by many layers of earth and rock. When artificial intelligence is added, computers can quickly scan huge amounts of data and point out anything that looks unnatural or possibly man-made, saving researchers lots of time and effort. Another breakthrough is called spectral imaging. This technology looks at objects using many kinds of light, not just what our eyes see, but also infrared and ultraviolet light. This helps scientists detect chemicals or materials that may have been used by intelligent beings. For example, certain paints, metals, or man-made materials leave behind clues in the way they reflect light. Spectral imaging can be done from planes, drones, or satellites, allowing researchers to scan whole landscapes that are too remote or dangerous to visit in person. Scientists are also using advanced forms of isotope analysis. One method, called clumped isotope thermometry, can measure the temperature and chemical conditions when certain rocks or fossils formed. If these temperatures don't match what we'd expect from natural processes, it could suggest something unusual happened, possibly related to intelligent activity, like machines, industry, or artificial heating. Another useful tool is micro-CT scanning, which makes extremely detailed, three-dimensional pictures of very small objects trapped inside rocks. This lets scientists see fine details, like tiny tool marks or layers that look carefully built, without damaging the sample. It can help identify possible signs of craftsmanship or technology that are too small or fragile to examine by hand. One of the most fascinating areas of study is ancient DNA, tiny fragments of genetic material preserved over thousands or even millions of years. These fragments act as biological time capsules, holding secrets about the creatures that once roamed our planet. Scientists are beginning to use this incredible information not just to study extinct species, but to explore whether these creatures might have been influenced by intelligent forces, whether human or otherwise, through domestication or manipulation. Ancient DNA is like a microscopic record of life. Even after a species disappears, traces of its genetic code can remain hidden in fossils, bones, teeth, and even sediments. By carefully extracting and analysing these fragments, researchers can reconstruct entire genomes, revealing astonishing details about extinct animals and plants. For example, we can learn about their appearance, their diet, their behaviour, and how they were related to modern species. But beyond these traditional studies, there is a growing curiosity about something far more controversial and exciting. Could ancient DNA show signs that some extinct species were altered, bred, or controlled in ways that hint at early domestication or genetic manipulation? When we think of domestication, we often picture the familiar animals in our lives today: dogs, cats, horses, and cows. These creatures were selectively bred over thousands of years to emphasize traits useful to humans, like loyalty, strength, or calm behavior. Yet, what if similar processes were happening long before humans in their current form walked the Earth? Could some ancient species, now extinct, have been guided in their evolution by a force capable of intentional selection? The possibility opens a world of questions. How would scientists detect such patterns in DNA? What would qualify as evidence of manipulation? And what would it tell us about intelligence in the distant past? One approach is to look for genetic markers that suggest selective breeding. In modern domesticated species, these markers often appear as clusters of genes responsible for specific traits. For example, in dogs, genes controlling behavior, coat color, and size are often very different from their wild ancestors, wolves. If researchers find similar clusters in the DNA of extinct species, it could indicate that some form of selective pressure was at play. Even more fascinating is that these genetic markers might reveal traits that appear unusually advanced for their time, such as enhanced intelligence, social cooperation, or physical adaptations tailored for specific tasks. Take, for instance, woolly mammoths. These giant creatures lived tens of thousands of years ago, yet they displayed behaviors and characteristics that suggest remarkable adaptation to their environment. Their thick fur, long curved tusks, and enormous size were all specialized traits for surviving the Ice Age. While many of these features can be explained by natural selection, there remains the tantalizing question of whether some traits were influenced or accelerated through intentional guidance, whether by early humans or an unknown intelligent force. Could DNA analysis reveal patterns of selective pressure that do not fit neatly into natural evolutionary processes? Another striking example is the dodo bird, which vanished from our planet in the late 1600s. Its rapid disappearance makes it a subject of intense scientific interest. Studies of ancient DNA might uncover whether the dodo had traits suggesting it was slowly being domesticated, perhaps by humans who first encountered it, or by other means that we have yet to understand. Even small changes in gene frequencies over generations could leave subtle fingerprints, telling us stories of interaction, experimentation, or manipulation in ways that fossils alone cannot reveal. The tools scientists now use to explore these questions are astonishingly precise. Techniques such as genome sequencing, comparative analysis, and computational modeling allow researchers to reconstruct entire genetic histories. By comparing the DNA of extinct species with their living relatives, patterns emerge, patterns that sometimes hint at sudden changes, unusual mutations, or traits that would have been difficult to achieve through natural evolution alone. Every mutation, every genetic sequence becomes a clue in the puzzle of the past. These clues can tell us about environmental pressures, migration patterns, disease resistance, and even interactions with other species, including potentially intelligent ones. One of the most profound implications of this research is that it challenges our understanding of the timeline of intelligence and intervention on Earth. If signs of domestication or manipulation were found in creatures that lived tens of thousands or even millions of years ago, it would suggest that intelligence capable of altering life may have existed far earlier than currently believed. This could completely rewrite the story of life on Earth, showing that humans were not necessarily the first to experiment with the genetic potential of other species. It might reveal a hidden history of innovation, adaptation, and experimentation that has left traces in the genetic code of creatures long gone. However, interpreting these genetic signals is incredibly complex. DNA can mutate and change for many reasons, including environmental pressures, random chance, and disease. Scientists must carefully distinguish between natural evolutionary changes and patterns that might indicate intentional selection. This requires meticulous work, cross-referencing genetic data with fossil records, climate history, and archaeological evidence. Only by integrating all these sources can researchers begin to draw meaningful conclusions. Misinterpretation could lead to false claims, which is why scientific rigor is essential in this delicate field. Even so, the possibilities are thrilling. Ancient DNA could reveal that species we thought of as purely wild were, in fact, part of a more complex story of life on Earth, one that involved interaction, guidance, or influence by intelligent beings. It could show that the seeds of domestication and genetic manipulation were sown far earlier than previously imagined, offering insights not only into the creatures themselves but also into the history of intelligence and creativity on our planet. Each genetic sequence is a thread connecting us to a deep, hidden past, waiting to be unraveled. In the coming years, as technology continues to advance, the study of ancient DNA may open doors we cannot yet fully predict. It may help us understand how life adapts and evolves, how intelligence can shape the natural world, and perhaps even how humanity might approach its own role as a shaper of life in the future. The idea that extinct species could carry traces of domestication or manipulation is more than a scientific curiosity. It is a window into the profound, intricate, and sometimes mysterious forces that have shaped life on Earth for millions of years. It reminds us that every living thing, past and present, holds stories written not only in bones and fossils, but also in the invisible language of DNA, waiting patiently for us to learn its secrets. This field of research, blending genetics, archaeology, paleontology, and even philosophical inquiry, promises to keep scientists, historians, and curious minds alike captivated for generations. By studying the DNA of creatures long vanished from our world, we are not just looking back, we are peering into the very foundations of life and intelligence, uncovering hidden chapters in the grand story of our planet. The answers may redefine what it means to be alive, what it means to influence life, and how much of our world's history remains still locked within the tiny strands of genetic code buried beneath the sands of time.